はい、皆さんお集まりいただきましてありがとうございます。本日ですね、自由席となっておりますので、お好きなお席にお座りください。あと Wi-Fi はこちら今画面にスクリーンに表示している Wi-Fi となっておりますので、よろしければこちらご利用ください。ちょっと人がね多くなりますとちょっとつなぎづらくなる部分もあるんですけれども、よかったらこちらご活用ください。はい、あと電源タップのご利用もご自由にいただいて構いません。あと来場受付はですね、入り口提出の QR コードよりお名前のご登録をお願いいたします。はい、あと今回のツイッターのハッシュタグはですね、ETHGlobal東京となっておりますので、もしよかったらこのビルダーズセッションで得た学びをですね、シェアいただければなと思っております。はい、であと本日のご質問、質疑応答はですね、スライドというサービスを使って進めていきたいと思っております。はい、こちらの QR コードを読み取っていただければ、各セッションへのご質問を投稿することができます。でそれで一番ですね、投票が集まった質問をこの運営の方から投げさせていただければと思っておりますので、こちらご活用ください。はい、このオフラインでご参加いただいている方々、現地でご参加いただいている方々はもう挙手をしていただいて直接質問いただいても構いません。主にオンラインで参加されている方ですかね。オンラインで参加されている方、こちら YouTube 配信も行っておりますので、オンラインで参加されている方はこちらのスライドを使ってご質問をいただければなと思っております。はい、あとですね、ちょっとした告知というかご案内なんですけれども、今回共同で主催させていただいているアキンド Web3 ハッカソンプラットフォームのアキンドとしてですね、今回ETHGlobal東京でいくつかサイドイベントをホストというかサポートさせていただいております。ちょっとご案内させていただくんですけれども、その中の一つ、直近の来週の水曜日にですね、コネクストというクロスチェーンブリッジのプロトコルのアイデアソンイベントを渋谷で開催いたします。こちらがアイデアソンで$1500のプライズが出るようなイベントになっておりますので、もちろん無料でご参加できますので、もしよかったら一つクロスチェーンブリッジコネクスト、結構ETHGlobalもスポンサーめちゃくちゃやっている有名なプロジェクト、まだまだ日本ではこれからのプロジェクトではあるんですけれども、いち早くそのコアチームとコミュニケーションできるような機会となっておりますので、よかったらこちらもご参加いただければと思っております。はい、で2つ目がですね、ちょうど昨日アナウンスさせていただいたばかりなんですけれども、本日もリアルでですね登壇いただくタイコ GK ロールアップのプロトコルを開発しているタイコがホストで、このETHGlobal東京のアフターパーティーをですね、虎ノ門横丁の一部の店舗を貸し切って150人規模で開催する予定になっております。これもおそらくもうハッカソン会場のすぐ本当に隣のお店のめちゃくちゃいい場所を貸し切ることができておりますので、もちろん海外のプロジェクトの方々も半数以上集まると思うんですけれども、こちらも無料でご参加いただけるようなイベントとなっておりますので、よかったらご登録もいただければなと思っております。ちょっとキャパシティに限りがありますので承認制にはなるんですけれども、ぜひこちらもETHGlobal東京の打ち上げパーティーというところでご参加いただけたら嬉しいなと思っております。はい、でまたこちらもですね、アキンドの方でサポートさせてもらっております Web3 エンタメハッカソンっていうのを、テレビ朝日さん主催でやっているようなイベントもございます。こちらも開催中でして、 4月の17日の23時59分が締め切りとなっております。こちらプロダクトだけではなくてアイデアや企画も提出可能となっているようなハッカソンになっておりますので、もしよかったらプロダクトは作れないけどアイデアはあるみたいなような方はぜひご参加いただけると嬉しいなと思っております。270万円のスポンサーフィーとスポンサープライズとなっております。こちらもですね、ETHGlobal東京ハッカソンが終わった次の日が締め切りとなっておりますので、今回のイーサリアムのハッカソンに提出したものだったりとか、あとはこのハッカソンの期間よりも前に開発していたものも提出 OK となっている、結構間口を広く取っているようなハッカソンとなっておりますので、ぜひこちらもチャレンジしてみていただけると嬉しいなと思っております。はい、ご案内としては、以上になりますかね。はい、では今しばらくお待ちください。はい、じゃあオープニングにちょっと先立ちましてですね、今回スポンサードもしていただいているちょっと別産よりご案内がございます。はい、入りました。でちょっとオープニングの挨拶の前に先立ちまして、ちょっとはい、別のじゃあ勘太郎さんからご案内お願いします。
はい、ありがとうございます。ベスラボという会社の、ファウンダーの藤森と申します。よろしくお願いします。今日は本当にこういう機会に、スポンサーで参加させていただいて非常に、嬉しく思っていますし、いろんな方とお話できたら嬉しいなと思っています。で、ちょっと簡単に今日受付で、お配りさせていただいているんですけども、私たちが、作っているベスカードというのを作っていまして、でベスっていうのが分散型の、Web3 のデジタル経歴書みたいなものを作れるサービスを僕ら作っているんですが、それの NFC カード版を作りました。なのでぜひですね、このカードを読み取っていただいて、最初セットアップしていただくと、ご自身のデジタル名刺みたいな形で使えますので、ぜひ試していただけたらと思います。であとここでそれを読み取って、セットアップした後にですね、他の方にぜひちょっとお近くのビルダーの方とかにですね、読み取っていただいてもらうと、今日自分と出会ったよっていう証明がお互いに発行されるようになってますので、発行した証明をもとにですね、連絡先を登録しておけばそこが連絡できたりとか、その人の実績を見れたりとか、そういうことに使えますので、ぜひちょっと、試してみていただけたらと思います。はい、ありがとうございます。
はい、じゃあ別の神太郎さんありがとうございました。はい、じゃあはいでしたらですね、じゃあそろそろメインセッションに移らせていただければなと思うんですけれども、はい、じゃあ皆さん改めて本日はお集まりいただきましてありがとうございます。どうもどうですかね。じゃあ最初のセッションとして、じゃあちょっとイーサリアムジャパンのマサさんから、はい、じゃあお話しいただいてもよろしいでしょうか。 けてもらっていいですか。はい、じゃあマサさんお願いします。
Okay. Hi, GM. Welcome to ETHGlobal Tokyo Builders session. I'm Masa from Ethereum Japan. So I'm super excited to be your host for today's gathering. This event is organized by Akindo and Accenture and Ethereum Japan. Akindo in particular put into a lot of the efforts to make this event success. Thank you, Kinjo-san, and thank you, Akin team. And as you know, so ETHGlobal Tokyo is in next week. It's a 3 days hackathon. And actually, there are a lot of the ETHGlobal hackathon in globally. And so actually, so today's half of today's participate will participate the hackathon. And let's build something interesting. And there are a lot of the workshop, learn something new. And of course, you can meet the new friends. And let me explain the Ethereum Japan. Ethereum Japan is started in 2018. It's a photo of the first event. It's Ethereum Japan community meetup supported by Ethereum Foundation. I and Vitalik and other Ethereum Foundation members came to Tokyo University and they presented what is Ethereum and what is roadmap and their Ethereum Foundation philosophy. And next year, so there was DevCon Osaka. And this is a big event around there were 4,000 people in there. And Ethereum Japan had some events called Road to DevCon 1, 2, 3, 4. It was the privacy and security and the UI UX event. And recently, of course, we had some events with Ethereum Foundation or developers. And in summary, so what is Ethereum Japan? So Ethereum Japan is a grassroots community in Japan. There are a lot of the local Ethereum community in globally. We are one of them, the Japan-based community. Our purpose is very simple. It's to make the Japanese Ethereum community fun and active and to promote the use of Ethereum. We held and we will organize the EJ meetup and a study group with developers and the business side. Of course, we will co-host the events as well. Our next event is the next day of the ETHGlobal Tokyo. It's a East Tokyo meetup on Infinite Garden. So capacity is already over though, but you can apply as a waiting list. Please apply. Yeah. And we are willing to collaborate with you. And if you want to get new information about the Ethereum community in Japan, please follow us, the Ethereum Japan account. Okay, enjoy today's event and enjoy ETHGlobal Tokyo. Thank you.
はい、イーサリアムジャパン、マスさんありがとうございました。はい、次のネクストセッションはですね、スケールネットワークのジェイソンさんにこちらオンラインでのご登壇となっております。少々お待ちください。ここに移してもらっていいですか。
Hi, Jason. Can you hear me? Sorry,
hello. Yeah. Hi.
Jack.
How's it going?
Yes. So, yeah, you have the floor. You can start presenting. Yes.
What's that? Sorry?
You can start presenting.
Okay. Am I live?
Mm-hmm.
Okay, great. Excellent. Hi, everybody. Well, I will start sharing slides. Does that sound good? 大丈夫です。大丈夫ですか？
Yeah, you can start. お願いします。
ありがとうございました。Right. すいません。ちょっと待って。Okay. Hey, everybody. Hi, I'm Jack O'Halloran. I'm the CEO and co-founder of SKALE Labs. SKALE Labs is the core team behind the SKALE Network. The SKALE Network is an Ethereum scalability blockchain, and I'm excited to speak today about SKALE. So first off, I know we have a lot of builders here and a lot of people who'll be participating in the hackathon. I'm excited to be back in Japan. I haven't been to Japan for a while. I've actually traveled to Japan 60 times, over 60 times. I used to go there for work once a month. I live in San Francisco, but I really love Japan, and just phenomenal people, phenomenal culture, and a lot of hardworking developers I know building on Ethereum. So without further ado, let's get into details about SKALE. So one thing is, what is the SKALE network? We get this question quite frequently because SKALE is not a simple thing to describe, and I'm going to go deep into what SKALE is here in a minute. Is SKALE layer 2 plus? Is it a layer 3 network? Is it a sidechain network? Is it a sharded layer 1 network built on Ethereum? Well, we're going to go and dive into that. But what I will tell you is SKALE is built to bring Ethereum to billions of users. We are Ethereum friendly. SKALE's built and integrated with Ethereum. We want to help make Ethereum be successful and help Ethereum developers be successful. So SKALE is a multi-chain and modular network. And what that means is there's a limitless number of chains that can be created within the SKALE network. It's Ethereum native. It's connected to Ethereum. It's integrated to Ethereum. SKALE's high performance and full function. So it has 0 gas fees. And we're going to get into more details. So this is one of the most compelling things that we find about SKALE is that the end users don't have to pay gas fees, but there's still a sound, viable manner for validators to be paid and delegators to get paid for staking. SKALE is a proof of stake network where the stake actually lives on Ethereum and it's integrated to the Ethereum network. We've been around for a while. SKALE started in the end of 2017. There are already 18 EVM networks, all sharing security within the SKALE network. There's been over 62 million transactions on chain since June 2022. There are already 4 hubs. So there's all these chains, but they're also coordination blockchains we call hubs. And I'll tell you a little bit more about those later. There's been over 375,000 active wallets on the network since last June. And SKALE's also backed by some really great supporters that you see here listed, like Multicoin, Winklevoss, Consensus, Galaxy, Hashed, Signia, Blockchain, NGC, Floodgate, Hashkey, Arrington, and more. We also have 5 million token holders spread around the globe, over 90 countries. The SKALE community spans, and we consider everybody who has a token a owner of the network and a member of the DAO. So I'm excited to get into tech, but I do like to talk about this because there are already so much happening within the SKALE network, and SKALE, to my knowledge, is the first decentralized layer 3, layer 2 multi-chain network on Ethereum, and huge projects across gaming, Web3, and other categories are building on SKALE. And we're excited to see all of these great Ethereum builders, because when I say they're building on SKALE, they're also building on SKALE plus Ethereum. Before we get into the tech, I do want to talk a little bit about a Dartmouth blockchain testing research study that was released recently. They analyzed different either blockchain. SKALE is a blockchain, even though it's integrated with Ethereum. And they compared SKALE, which is an Ethereum scaling blockchain, with, as you can see here, Solana, Avalanche, Polygon, Phantom, and others. And SKALE was faster through this independent study from Dartmouth in terms of transactions per second and finality, time to finality. SKALE has instant finality. So the time to finality is all about how fast a transaction will come to finality when it has, taking into consideration the networking across the globe. Okay. So we're really, proud of all the developers that have SKALE's open source. There's many people contributing, And it was amazing to see all of the work from so many different people and so many different developers come together to create the world's fastest blockchain. Okay, most blockchains are one shared database. Scale is made of many, many blockchains, all right? And the interesting thing about Scale is that it's actually, as I said, integrated to Ethereum. It's an Ethereum integrated scaling network, and it's not one chain, but many, many chains. I want to get in, I'll get in now to Scale's approach to scalability. So monolithic blockchains can't scale. And today, the version of layer 2s we see are very centralized. So we need other decentralized scaling alternatives. And that's one of the reasons why people are who build on Ethereum are picking Scale as a scaling platform of choice. And obviously monolithic chains will be capacity constrained, and they either have to increase fees or decrease performance. And as L2s become centralized, there are other issues that come together. And we all know there's efforts to create layer 2 app chain environments to decentralize layer 2 scaling. And Scale is proud to say that there's already a functioning network here that is an app chain environment. These chains all pool security. The stake of each of these chains lives in smart contracts on the Ethereum network. And the Ethereum network works in concert with the Scale network to create many, many chains in this layer 3 world and layer 3 environment. Let's take a look at scaling. So historically in the Ethereum world, we've looked at, and I'm pointing here, I'm looking here at my screen, a blockchain, and then trying to leverage off-chain scaling mechanics where we're not running other blockchains, we're running software on blockchains, but we're running those in an off-chain computational model. We're not running a decentralized blockchain network. These are these layer 2 environments, whether they are typically leveraging technology that's living in a centralized environment in AWS or Google Cloud or some centralized area to host software, and then trying to leverage math proofs, fraud proofs, game theoretical mechanisms to push the security back to the mainnet. The issue is our fees. We have fees and we still have centralization if those fraud proofs are not live. And I think one of the issues with today's layer 2 environment is that the majority of the fraud proofs aren't live, and we're seeing a lot of trust go into one company, okay? And hey, there are goals to change this, there are goals to improve this for obvious reasons. Let's also take a look at traditional side chains. If you look at traditional side chains, you can have many, many side chains that keep growing capacity, or app chain networks where they have completely siloed validator environments. And the issue is you can keep getting unlimited capacity and increased speed, but you're going to be constrained from a security perspective. The security is not flowing between these chains. The security is broken. So a monolithic chain with a larger validator set will have more security than these siloed side chains or app chain environments like you see in Cosmos Network, for example, where each individual chain needs to have its own security. It's not sharing security across the different chains. The issue there clearly is just that you're getting speed and capacity at the cost of security. But let's look at Scale. The model for Scale is to have one validator set for pooled security and many, many blockchains that all are interoperable, but also are sharing a pooled validator set. And in a way, you could think of these blockchains rather than side chains, you could think of them as shards. Because sharded blockchains, I think people generally agree, okay, that's fine, the security is solid, because there's one set of operators, even though at the end of the day, the databases are broken into different quadrants or zones or pools. But what you're getting is still shared security at a base level, all right? And the other thing about Scale, it also integrates to Ethereum. So the staking lives on Ethereum. The slashing conditions live on Ethereum. the node assignments, the blockchain orchestration, the blockchain creation, all of that lives within a smart contract set called Scale Manager. It's all open source. You can see it on GitHub, and it's running on the Ethereum mainnet today, and it's been running since October 2020. So when we talk layer 3, even right now, every scale chain is running complete consensus, even though it has penalties and pooled staking across all of the entire network that plug into the Ethereum mainnet. For purposes of speed and user experience, consensus is finalized on each chain. Bridging leverages a threshold mechanism, a BLS threshold signature. But what we are implementing in the future is something what we'd call a configurable and optional ZK. And so let's say you have an application that requires greater security and you're fine with higher latency and higher fees. Well, you can turn on or configure that chain or your deployment to that chain with heightened security and leverage ZK, and leverage zero knowledge proofs. So we're excited about that. It just adds more power, more security to the Scale network, and more configuration options for different types of applications that have different needs. All right, so we're going to get into pooled security and modularity. I talked a lot about this, but let's go a little deeper. So first and foremost, scale chains are all part of one network, and the Ethereum mainnet is there to run a random number generation in coordination with BLS threshold signature and a DKG or process that will randomly create a cryptographically secure method to have the right entropy to pull chains or pull nodes into certain chains and to prevent collusion. Because when you think about side chains, the issue with side chains is that they're susceptible to collusion, and you have less validators, so your security is less. But if you can randomly pick and rotate, then you have this small set that's fast and agile, but a bigger set that is your herd protection or group protection. Okay, and right now there are about 160 nodes in the Scale network. About 48 validator orgs are running those. And the network's been running, as I said, since October 2020. At the end of the day, what's being delivered is what we like to call a decentralized blockchain on demand, or decentralized blockchains as a service. The way this works is that each node is containerized. So there are Docker containers that run within each Scale node. And what we have is these modular blockchains. So every node has the ability has a core that's dedicated to running the network and making sure the network functions and secure, and that there's node rotation, node orchestration, slashing, etc. Staking rewards are given. Each node has to play a role in running the network, but it also can delegate components of its computational power to separate chains. Okay, so each node at the end of the day has 8 subnodes. The subnodes all can participate in a different blockchain at any given moment, and one chain is comprised of a subnode from 16 different or each chain is comprised of a subnode from 16 different nodes in the network. Okay, and what we're trying to do here with each chain is, one, create an environment where there is an allocation or distribution of computational resources across the network, but 2, pool security, because the larger the network and the more rotation and random sampling and redundancy there is, the more chains that can exist, where we're growing security by stacking and separating, getting horizontal growth or linear scaling, while having pooled security at the base. Okay, and I'm happy to say this exists and it's live today. All right, so one challenge. Let's talk about a challenge. One of the challenges of having lots of chains is coordination, because if you look at the way Ethereum has been built, connecting to 18 chains or 180 chains or 1,000 chains. That is not the way the ecosystem works right now. Ecosystems, marketplaces, DeFi, it wants to be centered around a chain. So there are hubs. Right now, there are 4 hubs in the Scaleverse, and there are many of the games and metaverse products that are connecting into these various hubs. And what we're doing is we're having coordination. So it makes a network agile. It helps with token mapping, helps with routing. And each of these chains, by the way, and hubs, there's free bridging. There's a BLS threshold encrypted messaging layer that allows for seamless transfer of assets or arbitrary data from chain to chain. All right, so there's a new product that's launching that, and I say product intentionally because you don't typically see blockchain protocols have a productized component, but Scale Connect is what I would call a productized component. Even though it's free, it comes with every chain. If you're an application's renting a chain in a decentralized manner from the network, you can deploy Scale to Connect. What Scale Connect is it allows NFTs on the Ethereum mainnet to be used in the Scale network. Okay, and we all know Ethereum is the best place in the world to mint an NFT. It's where the vast majority of NFT value lives, the vast majority of NFT volume, and the vast majority of marketplace activity all happens in the Ethereum network. And so what Scale Connect does is enables NFTs on the mainnet to be utilized and connected to smart contracts on the Scale network. So you could run and what happens is every Scale chain also has an integrated oracle. It's natively integrated because Scale uses a trusted execution environment, SGX container within each, or SGX component, TEE, within every single node. And it has a leaderless BFT consensus, has all these component parts for an oracle. And so the Scale oracle, one thing it can do, it can look at the Ethereum mainnet and say, oh, does this user have the NFT? Well, if that user has it, well, then they can operate as if that NFT were bridged to Scale. But let's say you have an ape or an Suzuki or some NFT over on the Ethereum mainnet, and you want to use it over on a game in Scale. And the NFT community says, hey, let's go use our penguins or over in a game that we're launching. Well, people don't want to lock really expensive NFTs. They don't want to lock expensive assets. And so what they can do is they can allow these assets to live freely, purely with the security of the Ethereum mainnet, and use the Scale oracle to connect and then signal, yes, this user A does have it, they can use it. B, yes. C, D, no, D can't use it. D doesn't have the NFT, that user can't go and use the sword in this game. But let's say user C sells that sword to user D, 0xAB79G4, whatever the hash is. All of a sudden, Scale oracle will recognize that user has it, but user C doesn't. And you can use Scale in a zero gas fee environment where Scale tokens are paid by applications to rent the chain or a subcomponent of a chain. The unit economics are far better than a per transaction fee validator model, where the validators get paid monthly in a decentralized manner by having a binary score of success in terms of their uptime, their SLAs, their latency, their ability to execute with accuracy and high performance. And there's a monitoring system that will pay them, but what that does is it creates a much better environment for economics. The other thing about Scale Connect is that an application, any application can authenticate can implement a method that will let the user sign in the Scale network without even needing to know they're there. So you can be connected to Scale's RPC, that chain's RPC address or RPC IP address and RPC endpoint, and the user still, as you can see here, and feels and sees that they're on the Ethereum mainnet. Unlike, in these other, or unlike typical layer 2 environment where users have to have this mental understanding of chains to switch IP addresses and ports. So we let this invisible experience happen, and end users can very quickly, easily integrate and connect to Scale. without even needing to know they're there if they're using Scale Connect. Okay, so if anybody has interest, I welcome you to join the Scale Discord. You can go to scale.chat. It will send you there. Also, if you can go to scale.space, you can get learn more about Scale, access the developer documentation. Here's my Twitter address and Scale Network's address, Twitter address, or just email info@scalelabs.com. So I know we're going to have time for questions now, but it's been my absolute pleasure speaking to everybody.
All right, thank you so much.
And I don't know. Yeah.
Okay, Jack, thank you so much for your presentation. That was very cool. Okay, so let me ask if anyone have a question, please raise your hands. もし質問等ございましたら手を挙げていただければと思います。Okay, Jack, I think your presentation was too good. No one have a question here.
ありがとうございます。
Okay, ありがとうございました。
ありがとうございました。
So, okay, thank you so much.
Thank you,
we'll
everybody.
see you soon. Thank you. Okay, next will be Mina Protocol. So give us 5 minutes, Ron. Okay, it's coming now.
Clearly?
Okay, hi.
Hi.
You Jensen?
Yes,
okay,
I
nice to
am.
meet you. I'm Taka. So your presentation is ready now. Go ahead and start your presentation. And thank you for coming today, though.
Oh, yes, and thank you as well. I appreciate the opportunity.
Thank you.
Oh, well, I see my head on screen now. Hi, I'm Jason Steinhauser. I'm an engineering manager here at Mina Foundation, and we're the custodians of the Mina blockchain and its growing community. And I'm here to talk to you right now about how Mina is helping to build a privacy and security layer for Web3 utilizing zero-knowledge smart contracts. So here's kind of a brief overview of what I'm going to be covering today. So we'll touch on how data privacy is kind of transformed throughout the internet history, how Mina is working towards enhancing privacy, as well as some near-term data governance issues that can include Mina as a solution. Right, so we say that we're building a privacy layer. Well, what does that really mean? All right, let's kind of take a look at where we started out, where we are, and what we're kind of planning to build out in the future. So you know, back in the days, the prehistoric times of the internet, like the early 1990s, the internet really didn't resemble anything like what we know of it today. Most of the web pages were static. Many of the bidirectional communication channels we had were light on privacy. There was really no idea of a digital asset beyond your self-hosted website, or in my case, like a GeoCities hosted website. So enter Web 2. So we have moved on to interactive websites. We've got some digital assets like digital music, movies, that sort of thing. But a lot of this interactivity came with a little bit of a drawback. We all know that Web 2 is kind of defined by centralized platforms, and they kind of control a lot of data about us. I know you've heard the expression, if you don't pay for the product, then you are the product. Well, this is kind of the core business model for a lot of companies and a lot of different market verticals, and the industry of surveillance capitalism. And I mean, let's not forget to include like data breaches in this. Sure, you know, a lot of companies have been getting better about protecting data they've collected on you, but I mean, how many data breaches have affected you and the people that you know? Well, in this transition from Web 2 to Web 3, it's representative of the evolution of decentralization of that control, giving you control over your data. So how do we get there in Web3 to this proverbial promised land? Well, we get there by developers like you guys building decentralized applications. So privacy, if we're building it, kind of how are we defining it? Well, privacy is a fundamental human right, and it's recognized in many international agreements, such as the UN Declaration of Human Rights. And there are multitudes of laws and regulations concerning privacy. The Web3 definition of privacy is broadly defined as the ability to decide what you want to share and who you want to share it with. This can be some combination of your identity and your actions. So, for example, you can send messages to friends privately so they know who sent the message, and only the friends you have shared it with can read it. Yes, I understand that I just described Signal, but it is a great privacy mechanism. And in some cases, you may wish for your identity to be private. You may want to remain anonymous, but not necessarily care if your actions are anonymous. So, using some sort of pseudonym or screen name to post messages on a social media platform, or maybe donate funds to some cause or charity that you're interested in. And I know it sounds really ridiculous to even have to say this, but kind of believe that data about you should actually be your data in your control. So, just kind of a brief summary here of where we are right now with Mina. If you're not familiar with our brief history, Mina is a layer 1 protocol that was incubated by O1 Labs, and they've been working on this since 2017. They spent a number of years working on the design of the chain, as well as working with recursive zero-knowledge cryptography, with the goal to implement a blockchain that uses ZKPs natively on a layer 1. We launched mainnet just over 2 years ago, and we're actually working right now towards a huge protocol upgrade, assuming that the community votes to accept it. But we will be bringing our zero-knowledge smart contracts, or we call them ZK apps. We're going to be bringing those to our mainnet. In the meantime, we still have test nets where you can tinker with ZK apps. So what exactly is Mina? We like to describe ourselves as the world's lightest blockchain. With using some recursive ZKP magic, we are able to get any node that wants to spin up can participate as a full node and can participate in consensus without keeping the entire history of the blockchain on disk. All they need is a proof of the blockchain state that takes up about 22K of disk space, the size of a couple of tweets, really. So we're pretty easily able to get nodes up and running. I mean, we can verify the entire state of the blockchain in just a matter of milliseconds. And we don't have to trust some third-party node operators if we don't want to store the entire chain history on disk. I mean, that makes us a little bit more trustless and therefore a little bit more secure. So apps built with Mina, they're powered with, like I said, our ZK smart contracts. And because we're only committing a proof to the chain, we don't need every node on the network to re-execute every single command or transaction. So yeah, I think that's a very compelling case for privacy. So yeah, with other layer 1s, well, you've got blockchains that pretty well grow over time. And usually if you're going to spin up a brand new node, you've got to validate all the transactions that have ever occurred on these chains. So that's a whole lot of data. For example, Bitcoin, it's over 400 gigs now. Ethereum's over 1 terabyte, I believe, worth of transactional history. In contrast, if you wanted to prove Mina's transaction history, like I said, you just need a single proof of around 22K. And sure, we do have archive nodes that do capture all of previous transactions, but Mina end users, by and large, they can validate the entire chain securely and quickly. And we actually have shown that we can do this from a web browser on a mobile device, which I think is really cool. That's that's kind of really approaching what I view as like a truly decentralized network. And I don't know about you guys, but I think that's really cool, technically speaking. All right, so let's see what some of the advantages of our ZK apps are. So if we think about, most dApps or, EVM-based dApps, when you use this application and you'll send a transaction, that transaction will contain some instructions to update the application state. So those instructions get sent to every node in the network, and every node in the network runs every instruction. And as I mentioned before, anytime you try to bring up a new node, they have to run all of those transactions for those dApps as well. So as we can pretty well see, that's not very efficient either in time or disk space. And also, there are no elements of privacy really there inherently, because a lot of the trust that you're getting from your dApps is because all the data is public and out there. So Mina has decided to use a different model. Users execute one or more methods on a smart contract locally on your device, and you generate a type of a ZKP called a ZK snark. I've mentioned it already, but it stands for Zero Knowledge Succinct Non-Interactive Argument of Knowledge. The user then will send a transaction containing this snark and a description of the associated state updates to the chain. The Mina network then will verify that this proof is correct for that for your ZK app account. And if the state is allowed and proven, then it'll be updated. And if not, then the transaction is rejected. So yes, kind of like I alluded to, since a lot of the computation happens off chain, you can keep a lot of your data private, and we can prove it via zero knowledge proofs. So this is I don't know, these are huge advantages, because we're not having to rely on every single node in the network to validate every single instruction. So how do we go about deploying a ZK app? Well, when we compile them, they compile down into two things. There's the prover function, which is actually what you'll run locally on your device, and you will tell it exactly what to do, and it will generate a proof showing you that it did so correctly. And this is the proof that we can actually send to the chain. We'll also deploy a verification key on chain, and this is actually what gets stored. And let's see, that is actually what will get stored and contains all the business logic for your smart contract. So that way you'll be able to verify any of the proofs that you have coming from your smart contract with that verification key. So like I just mentioned, when you deploy it, when you deploy the verification key to the chain, it will create a ZK app account on chain for it. How does this work? Well, future transactions sent to the ZK app account, they've got to contain a proof that the transactions and the state updates were valid. My gosh, okay. So if the proof isn't verified, then the ZK app state is not changed. It's got to be a valid proof. So how can we get started writing smart ZK apps right now? Well, we have worked with, and primarily OF1 Labs has developed a library called Snarky.js. It's a little bit of a misnomer because it's actually a TypeScript library. And that's kind of how we're building all of our ZK apps right now. One of the great things that I like about this is that everything is in TypeScript. That's already got great tooling. You're already familiar with it if you've done any sort of front end or web development. So you get to keep using all the tooling that you're familiar with. And one of the other great benefits here is you get to leverage the use of zero knowledge proofs without having to know any of what Vitalik calls moon math. You don't have to research plonks or rank one constraint systems, inner product arguments, nothing like that in your spare time. All you really need to do to leverage ZKPs is to install our CLI from Node Package Manager, read some of the tutorials and you could probably have a ZK app deployed by the time you go to bed today. So, I mean, what kind of things can you build with this? I mean, you can build a whole lot, but some of the more privacy oriented ones we have, privatized DAO voting, and actually we're actually piloting voting on chain right now with some of our Mina improvement, some of our MIPs that are being voted on by the community right now. Anything using real world financial data would be great. I mean, it'd be great to be able to prove that you're credit worthy by getting your credit score from Experian or Equifax, being able to have a proof of that you transmit to the chain, but not the actual underlying data, as well as maybe providing proof of income from Gusto or ADP or whatever whatever payroll system that your company uses. This could be very effective, or this could be very handy when trying to get a loan for a car or a house, things like that. We're able to safely interop between private enterprise data with our public smart contracts, ZK apps on chain. This is something that I believe the baseline protocol was hoping to accomplish, but this is just something we can support outright because of how we've designed the chain. It's also very easy to spin up some ZK rollups because, I mean, let's face it, Mina is essentially a giant, one giant ZK rollup where recursive snarks all the way down, similar to Polygon's ZK EVM that they had just released. In the essence of time, I'll skip those. So that kind of begs the question, since we're here at an ETHGlobal workshop, can Mina actually play nicely with other chains and other dApps? Well, because we're here, yes, yes, we can. So how can we do that? Well, I mean, it makes sense to be able to have some data privatized on Ethereum, but ZK snarks, while they are succinct and use very little call data, they are kind of high on the gas fees. Another option that Starkware has gone with are ZK Starks, the zero knowledge, scalable, transparent arguments of knowledge. There we go. They are faster to compute, but their on-chain data is it's not of a consistent size, and a lot of times it's larger, and we know more data is more costly. So with Mina, we're able to leverage ZK snarks at a layer 1, and we're able to provide, and right now, thanks to one of our ecosystem partners, the NIL Foundation, we're able to securely bridge Mina state over to Ethereum. So we can prove things about the Mina, the state of the Mina chain, over on the Ethereum blockchain. The NIL Foundation is doing some incredible work there, and I implore you to check it out if you get a minute. Also, we want to be able to bridge back from Ethereum to Mina. While that is possible right now, it's incredibly slow. But we've actually got some Mina improvement proposals out right now for adding additional gates to our proof system, which we call Kimchi. We're looking to add some gates to that to make proving Ethereum state on Mina even easier and faster, and looking forward to that coming up in the next quarter or so. So stay tuned for that. Stay tuned for that, because that's going to be really nice to be able to bridge between anything to and from anything EVM. So yes, like I said, we're able to verify the most recent state, the canonical chain state with Mina's actual chain selection rules. And yeah, anybody can actually go and update that state on NIL's ZK Bridge contract to update the current Mina state on Ethereum. And Yeah, and like I said, yeah, like I said, they're to 0.3. We're using the strongest state according to the Merkle root on the ledger. So yeah, I think that's it from me as far as an overview on Mina. This is I've got stuff on here on GitHub and Twitter for how to find us, how to find me, how to find O1 Labs, and link to our docs as well. And yeah, I think that's it for the presentation.
All right, thank you so much. Thank you for your speech. We actually have a question from online, but let me ask if anyone have a question here. Please raise your hand. Yeah, either Japanese or English is okay. Okay, we got one question here.
Okay.
Do you speak Japanese, Jason? No?
Hi.
Okay, just kidding.
Yeah.
Okay.
どうぞどうぞ。Thank you for great presentation. I'd like to use Mina in the project I will submit to the ETHGlobal Tokyo. And I have one question. What is the difference between verifier function and verification key? What is the difference?
Yes. Okay. So the all right. Let me see if I can get this straight. It's late here. Let's see. So one thing that we've got to do with the zero knowledge proof, when we compile it, we get the. My gosh, I feel like I'm going to screw this one up. Again, the verification key is essentially a mechanism that we can use that the prover has committed to ahead of time. It's kind of a way for us to keep a trustless setup because there's actually a there's a public commit that we can use to include that we have to supply to the prover function to prove that we actually did the calculations correctly. I am certain that didn't really answer your question. Is there anything that you would like for me to try to clarify?
Verify?
Say again?
My question is, what is the difference between verifier function and verification key?
Yes. Okay. So, based on when you generate when you generate the proof, you will also generate when you compile the smart contract, you get the prover and the verifier, and then when you pass the proof over, you have to, or when you pass the proof to any of the other validator nodes, it's got to have that verification key. It's kind of like it's kind of like a private key, like if you're looking at if you're looking at some sort of cryptographic handshake to be able to say, yay, verily, this data is kind of signed correctly, if that makes any sense. I should this is one that I should have done my homework on to have a better answer for you. I apologize about that.
Thank you very much. I will check the documentation by Mina. I will.
Okay, yeah, and feel free to reach out. And I will get an answer to you. Username on Twitter is right there, so yeah, feel free to reach out.
Okay, thank you very much.
All right, thank you so much for your question and answers. So, anyone else have a question here? Okay, so I got one question from online. Okay, I'm gonna read it out. So, do you think ZK is overvalued? Do you think it needs a major overhaul? That's a question. Did you get it?
Right.
Yeah, okay, thank you.
Yes. So ZK, I don't feel is overvalued. I do think that there may be some resistance to larger adoption of ZK, but no, I mean outside of blockchain as well, zero knowledge proofs have, I mean, they have lots of other uses outside of blockchain. One interesting case would be if, let's say, first responders, you know, like firefighters, ambulances, things like that. If they're arriving at a scene, you know, at the scene of an accident, then they may want to make sure that everybody else that's showing up has, you know, has the credentials to actually be there and are in the right jurisdiction. So there are applications for ZK outside of the blockchain as well, and so that is one big reason why I do not feel it is overvalued. It's because I mean. It has a lot of off-chain uses as well. So yeah, I'm a firm believer in it.
Okay, thank you so much. So second question is, do you think it needs a major overhaul?
Say that one more time.
Yeah, do you think it needs a major overhaul? Overhaul? OVERHAUL is it overhaul?
Oh, yes.
Yeah, thank you.
Does ETH need a major overhaul?
Yeah.
I don't know. I have seen a lot of ZK related things on Ethereum coming up in the roadmap. Gosh, what was so I don't think Ethereum necessarily needs a major overhaul. I think it is already on the right course to adopt ZK more at its base layer. But that being said, it's going to take some time for Ethereum to get there. So while there are gradual improvements, I mean they are definitely warranted. But yeah, I don't think a major drastic overhaul is necessarily in their best interest, if that makes sense. I mean, yes, there are some things that have to change about Ethereum in order for this to be more widely adopted, in my opinion. But no, I don't think a major overhaul is necessary. We've already got other solutions even sitting on top, Polygon and Starkware, and Scroll, and I'm sure I'm forgetting some others as well. There's already great examples of ZK that is actually L2s on Ethereum right now. So no, I don't think it needs a major overhaul.
Okay, thank you so much. So if there is any other, we have no question here, then we'll move on to other protocol presentation. Okay, thank you so much, Jason, for today coming here, and I wish we will meet you in Japan sometime soon. Okay.
Yes, that would be great. Thank you, Kinjo.
Thank you so much.
Thank you so much.
Yeah,
Bye.
Bye.
Okay, next will be. Okay, we got a slide. I don't know how to pronounce this one, but you can scan with your phone and you can ask question here too if it's hard for you to write out. So please use this to ask question online. Thank you. So next speaker will be Jon from Hyperlane.
OK。じゃあもうここに入ったら行くと思うんで、来ないんですね。
少々お待ちください。
Hi John, can you turn on your camera?
I'm sorry, I can hear you.
Yeah, thanks. It's okay. yeah, you can start your presentation. So
Terrific.
this is a presentation from Hyperlane by Jon.
Everyone, thank you so much for being here today and for let me talk to you about interoperability. Today we're going to talk about specifically interoperability. We're going to talk about how that relates to modular blockchains and the modular blockchain thesis. I'm going to tell you a little bit about Hyperlane and what we do here, and how Hyperlane's version of permissionless interoperability is really a requirement, or perhaps the missing piece for blockchains to reach their scale by realizing the modular blockchain thesis. At Hyperlane, we have this thing, we call it the interchain highway. What is it? This is, if some of you have played around with Midjourney, this is what Midjourney seems to think the interchain highway is. Before we get into all that, let's start with the state of blockchains and a little bit about interoperability. So we have these really cool internet computers. These internet computers are creating loads of valuable state, but these internet computers are isolated, right? So if you've spent any meaningful amount of time in crypto, you've realized that natively, most chains, particularly the interesting chains, the ones in EVM land, really can't talk to each other. Everyone here, for the most part, knows that. We know that we have some type of mechanisms to communicate between them, whether these are the token bridges that have become more popular, or sometimes we'll have a architecture like Cosmos and IBC, where if you conform to that architecture, you can get some type of communication between your internet computers. But without it, the valuable state that's created on these internet computers really can't be accessed by any other one. Another point is that to the extent that you can communicate between chains, if you're going to do something between them, as a developer, you can deploy on multiple chains. Often just means creating an isolated instance of your application, right? So developers can really only serve users on those chains that they're already on. And a new deployment, expanding to a new chain, often means that you're not benefiting from your previous ones. So you go through all this hard work, you build a company, you build a team, you create an application, let's say on Ethereum or on Arbitrum or on Avalanche. Now it's time for you to take the next step. You want to start catering to another market, you want to add Solana. By and large, with the exception of leveraging your brand, you don't really get to leverage the network effect that you've created. Now, another thing that is very common probably for everyone in the room, in crypto, when you introduce a new user to the system, they often interact with infrastructure well before they ever reach applications. This is something that all of us probably know isn't tenable or agreeable or even acceptable. And it's definitely not like the destination. It's not where we want crypto to be as a mature technology. So like, what is? As we transition this destination, we reach a point in time where demand for crypto services grows. And with this demand, we keep on a recurring basis running into scalability problems, right? The easiest way to express those scalability problems is with the image I have here about the gas being too damn high, right? If you think of blockchains as they are constructed, these internet computers, the one thing that we know that they do is they make digital resources scarce, right? That there's only so much block space, and if you and I and another 1,000 people in the world will all want to use it at the same time, we have to pay for it. We have to kind of bid against each other. And so what are some of these solutions to these scaling woes, these problems that we have? The most popular one seemingly today is what we call the modular blockchain thesis. This is going to transition us to a world where there are going to be more chains, but smaller chains, right? A brief on the modular blockchain thesis. We'll spend some time on this during the talk today. It's this notion that you can separate what is a monolithic blockchain stack, where execution, settlement, and data availability are all handled in the same environment. You can separate those three layers, and now you can have many more chains handling only execution and relying on others larger, maybe hubs for settlement and data availability. And so in this world where we're solving some of the problems where we didn't have good communication, where we didn't have good user experience, and we had scalability woes expressed as high gas fees or like high latency, we're going to end up with more and more chains. How do we deal with that? How do we solve that? So today we'll see why permissionless interoperability is the key to realizing the modular blockchain thesis. So what's going to be a more acceptable state for us if we organize it today? Isn't that? It has to be better than where we are today. So let's if the modular blockchain thesis is going to be something that solves the scalability problems and solves some of the infrastructure problems, it's not going to be complete without a way to communicate between all these chains, a way for that communication between chains to be both seamless and easy to use for the people who create them. It's going to have to be a state of the world where your interactions with infrastructure are far fewer than your interactions with applications. Again, this is not going to happen by virtue of magic. Someone has to do it. That's what we're trying to do here. So before we get into Hyperlane specifically, it might take a minute to talk about this interoperability on the whole. Normally, I'll go through what I talked about with areas of interoperability, how the category has really progressed in the last 7 or 8 years of blockchains. Today we're going to be a bit short on time, so we're not going to do that. But if you wanted to take a second to look at the slide, think about there being 3 primary areas of interoperability. One, I like to call defined rule set. This one looks a lot like Cosmos or Polkadot, where you're proposed a construction or a framework for how to build a chain. And as long as you conform to that structure, you can get pretty strong interoperability guarantees. So this is like building a Cosmos SDK chain and then using IBC with it. This is becoming more popular as we're seeing with the rise of these app chains. By late 2019 and early 2020, we started seeing a form of asset-centric interoperability where token bridges became very dominant. This seemed to work out quite well, but certainly had a lot of woes with it, as we've all seen from the many hacks of these token bridges. And in the last year, thanks to solutions like Layer 0, Axelar, and Hyperlane, we're starting to enter this mode of app-centric interoperability, where instead of just token bridges, we have applications that are connected between chains and then handle the burden of interoperability on behalf of users. An important thing for us to talk about today is not just the types of the history of interoperability, but really the different flavors of it. If you're going to understand how to use it, how to think about it, you really want to think about 2 different main flavors. The first one, let's call it the more ideal one, is native verification. In native verification, you're leveraging the consensus mechanisms of the chains that you're connecting. As you can see in this diagram here, all you really have to trust are the chains that you're connecting between. So if you have a chain A and a chain B, a native verification mode of interoperability really just relies on those and has no additional trust assumptions. So if you're comfortable with the first chain that you're sending to and the second chain where you're sending from, native interoperability works very well. This sounds really nice. Why wouldn't we use this everywhere? The reason why we can't use this everywhere is because to do that, you really need to replicate consensus of the sending chain on the receiving chain and vice versa. This is prohibitively expensive unless those systems were designed to do so. So earlier, when we spoke about the defined rule set mode of interoperability, it is such where these constructions were designed to make replicating consensus much cheaper. Oftentimes, these are places where light client verification was created, as is the case with IBC compliant chains. And now On A, we can replicate the consensus of B, and on B, we can replicate the consensus of A, and this makes it far less expensive. If we wanted to replicate consensus in an environment that it was not meant to do so, where there is not native lifeline verification, such as the EVM, again, we can't do this on Ethereum just yet, or we can't do it cheaply, it is prohibitively expensive, and native verification doesn't work so well. So we might look, don't lose all hope yet. We're going to get to a world where native verification will probably become cheaper and cheaper and more available. But until then, do we just don't do anything? No, we are going to use external verification. So the primary difference between native and external verification is if in native you only trusted the chains that you're communicating between, now you have to still trust both of those chains, but an additional validation mechanism, something in between them. And so you have to trust A, you have to trust B, and you have to trust some middle part C. If this looks a lot like the Oracle problem to you, where you have to introduce another trust mechanism, that's because it's the same thing. If anyone tells you that interoperability and Oracle problems are completely distinct, they're not being honest, or they don't know what they're talking about. Either way, beware. Certainly, if they're dealing with external verification, it is absolutely a variant of the Oracle problem, except instead of being a generalized variant of it, where you try to introduce all off-chain data to a chain, you're really only trying to introduce off-chain data that is data from another chain. But ultimately, same problem applies. So there's different configurations for external verification systems. The most common are multi-sig systems. We're starting to see more proof-of-stake systems. Additionally, we're starting to see some optimistic systems, and really, who knows what else we'll see in this flavor. But external verification can be done much cheaper, again, because we're not replicating all of consensus. It comes at the trade-off of trusting an additional party in addition to the chains that you're communicating. And of course, that has some major drawbacks, but it has major advantages, primarily that you can do it cheaply almost anywhere. Now that we covered the history of interoperability a little bit, let's talk about what we started about. Earlier, we spent a minute talking about scaling woes, the future of blockchains, and this demand problem that's going to arise if blockchains become very popular. The modular blockchain thesis has emerged as a solution that's kind of growing in its following and growing in its popularity as a way to solve the scaling problems of blockchains. Just to recap, if you're not familiar with it, all you need to know is that if current blockchains handle settlement, execution, and data availability all in one, the modular blockchain thesis is this notion that these can be separated into distinct layers of a stack, such that you can have smaller chains, and they don't necessarily have to be smaller, but you can have chains that only handle execution and then rely on others for data availability and or settlement. So in this world where modular blockchains are very dominant, what does it really mean for you? What does it mean for anybody? First and foremost, it means you're going to have a lot more chains, a lot more rollups, and you might have many more layers in rollups. So how is this going to work? What is it really going to mean for you? I think it's going to mean that there are going to be hubs. Hubs are going to proliferate everywhere. What is a hub? A hub, think of it as like a dominant layer one, a dominant settlement chain, a dominant data availability chain from which other chains that are execution only get some guarantees. So Ethereum right now is a major hub. It does not have that many rollups spinning out of it just yet, but it has several major ones, whether it's Optimism, Arbitrum, now Base. Additionally, the Cosmos ecosystem acts as a sort of hub with app chains springing from it. Celestia, which is going to launch is aiming to become a major hub for data availability. And if these hubs are going to proliferate, they're going to do so because many more rollups will stem from them. And again, how do you navigate this complex space where you have distinct hubs, many rollups coming out of those distinct hubs, and from those rollups, there might even be multiple layers of rollups? I think, and we think, that Hyperlane, that the modular blockchain thesis needs permissionless interoperability. You're going to have so many more rollups, maybe hundreds of rollups and chains, all of them flowing down to different hubs. They use these hubs for settlement, for data availability. And now, how are they all going to communicate? What good is a system where you can spin up your own rollup in minutes and then leverage Ethereum for your settlement and leverage Celestia for your data availability? If once you've created this rollup, it's like an island in the ocean, not connected to the mainland, not able to communicate with any other chains or any other rollups, not able to exchange assets or exchange economic activity between them. So for this exactly, we built Hyperlane. Hyperlane is the first permissionless interoperability layer. It's the only interoperability layer that can scale in a world where anyone can easily create their chain of rollup as easily as they can create their smart contract app. Think of it as the way that we allow anyone to bring interoperability anywhere. If the modular blockchain stack has historically been thought of to include settlement, execution, and data availability, Hyperlane is the last layer. It's the interoperability layer. It's the communication layer for this stack. So what is it? Well, first, it's not another blockchain to solve blockchain problems. What it is really, it's a network between blockchains, a network of networks, and it's the path between them. This path is what we've called before the interchain highway. It's our effort to create the safest, fastest, and most accessible way to traverse the empty space between blockchains. How does it work? We have these mailboxes. They do exactly what it sounds like. The mailbox communicates information or sends messages between chains and receives messages as well. So you as a developer have your contract. Your contract will send the message using the dispatch function. That's the primary interface for the mailbox. That now comes in Hyperlane's modular security stack, where a security module could be expressed through validators, could be expressed through watchtowers, looks at the mailbox and sees your message. If the message looks valid to them, they sign it. And now an off-chain agent, a relayer, which is a permissionless role that anyone can run. Right now, Abacus, our company, runs some relayers. Many of our users run their own relayers, and certainly most of our users who are running their own rollup, they run their own relayers as well. The relayer then, if the message looks valid, will deposit it and process it on the destination mailbox, where now the second layer of our modular security stack comes in. And you can choose from a number of interchain security modules. Think of these as the logic for how to process certain messages. They get triggered. And you can choose from a number of modules. A module can be something like a staking module, where you require that a certain amount of assets be staked to confirm the message. You can require an optimistic module, where a certain amount of time needs to pass, and during that time, anyone can observe the message and submit a fraud proof if necessary. Or you can have a multi-sig module, where you simply require the signatures from a pre-designated set of keys. You can also use these modules differently based on what your users are doing. So you can have high-value transactions, where maybe you want the combination of high staking of an optimistic module and the multi-sig module. And then you can have low value messages, where you simply care about speed and kind of quality of execution, and in which you only use something like the multi-sig module or only the staking module. So what's interesting about it? Well, beyond the permissionless nature of Hyperlane, certainly the modular security stack, which allows you to customize security dynamically based on what your users are doing. Hyperlane also allows you to build interchain applications. These are connected across chains in a way that now can have seamless interactions to users in a sort of improved user experience. Then we have interchain accounts and queries that allow you to interact between chains with minimal contracts needing to be deployed by you on those other chains. Perhaps most interesting for developers in the hackathon are the concept of warp routes. Warp routes are Hyperlane's take on bridging. Traditionally, bridging is done through an omnibus bridge contract. This is where all assets are deployed into the contract, and it holds all assets on behalf of everyone, kind of acting like a little bit of a honeypot for potential attackers. Then it spits wrapped assets that can move to the chains where they need to be. Hyperlane's take is a bit different. Hyperlane, again, was built with modularity in mind and has a modular security stack. So everything built with Hyperlane gets to benefit from these features. In the warp route case, a warp route is unique per asset. So we create a warp route for each asset type, and each warp route can have its own set of security modules and set of security definitions. Additionally, warp routes can be created permissionlessly. So you can always utilize warp routes for your assets. And when a warp route takes your asset and wraps it to create a new asset, it creates an interchain asset. An interchain asset is one that can easily move between chains. It can move as easily between Hyperlane supported chains as it could move, as a normal asset can move between addresses on a single chain. And so this is something where if you're trying to build an interoperability type of related project in the hackathon, you might want to use warp routes. And so with that, I know we have a few minutes left for Q&A. So let me know if you have any questions.
All right, thank you so much, Jon. Thank you for your speech. So if you guys have any question, please raise your hand. And I actually got 2 questions online. So I'm gonna read this first. So first question is, online chain bridges are often targeted by hacking. What measures will Hyperlane take in the future against hacking? This is the first
That's
question.
a great
for
question.
You.
So the first measure that we take is really it's our modular security stack. So each module is distinct from another, such that usually hackers target your entire security module. And this is prevalent because almost all bridges today, almost all interoperability protocols today, just have one security model, and all users of their protocol are always subject to it at all times. If you compromise that first model, you compromise the entire system. In the case of Hyperlane, there are 2 layers of defense. First, if you target a single module, you only impact the users of that module and not the entire system. And then second, with the second layer is, again, so you might compromise a module. Apps can choose to use multiple modules for different cases. So their entire app might not be jeopardized. Beyond that, we want to have the benefit from the wisdom of the crowds and the benefit of an open source community. So actually anyone can create their own modules. And we actually have a nice prize at the hackathon for people to create their own security modules. So we'd love to see some participation there.
Okay, thank you so much. So I got another question here. I might not understand well. Can you elaborate on what the difference between layer 0 and Hyperlane? That's another question for you.
Of course.
Yep.
That's a great question. So the primary difference is Hyperlane, again, is the only interoperability platform right now that anyone can deploy on any chain. So if you wanted to deploy Hyperlane on your own rollup, let's say for this hackathon, you want to try and win a prize from Optimism because they're giving prizes for people who use the OP stack, and you want to try and win a prize from Hyperlane. So you can create an OP stack rollup, and then you can put Hyperlane on it. So that's a primary difference. Beyond that, both Layer 0 and Hyperlane try and use modular architecture. Hyperlane's modular architecture is right now live, so you can experiment with these different modules. Layer 0 isn't live yet, but beyond that, they're quite similar in their concept. So the primary difference are the permissionless nature and the modularity. But other than that, Layer 0 is a wonderful project that really has done very well, and we're pretty stoked about what that team has done.
Okay, thank you so much.
Thank you very much. Have a great.
Do you have any other questions? If not, we will move on to the next speakers. So thank you so much, John from Highlands. It was very nice to have you here, and
it was great to
hope
have
to
you.
see you in Japan next time, and we will show you around.
See you in the booth.
Okay. See you soon. Thank you.
Thank you so much.
Bye bye.
Thank you, John. Bye bye.
Okay, next speaker will be Samuel from Worldcoin. Anyone knows about Worldcoin here? Oh, that's cool. Nice. Oh, there are a few hands I can see.
Ready when you guys are.
Okay. Hi, Samuel. Thank you for coming and joining us today. I wanted to see you in Japan actually, but it's fine. Okay, so
I'll be there next week.
Yeah, next week. Okay, I'll see you there then. Okay, so now it's time for you to give us a presentation. Okay, go ahead.
Great. Okay, and shall I share my screen?
Yeah, please.
Okay, here we go.
Okay, now I can see your presentation. Thank you.
I can still hear the waiting room music, yeah. Okay, so good to be here. Good morning, afternoon, and evening to everyone. My name is Samuel Barnes. I am the head of community here at Worldcoin. And I want to thank everyone who's presented thus far. Been tuning in and some really fascinating projects. So I'm really honored to share the stage and to present a little overview of what we are getting started with Worldcoin. So I'll be in Tokyo next week. Worldcoin is one of the primary sponsors of ETHGlobal that's going to be happening at the Toranomon Hills Forum. So I hope to see a lot of you there. And as I'm a community manager and not a technical lead or even a developer, I'm going to spend the next 15 or so minutes giving you guys the what, the how, and the why of what we are creating with Worldcoin. So as some of you might know, Worldcoin is a really broad scope venture with big goals and aspirations that go beyond what's typical of what we're used to in Web3. So as you can see here on the top of our homepage, we are building what we aim to become the world's largest identity and financial network as the public utility. And in the process, we're giving ownership to everyone. So far, that means that we've been in about 7 countries piloting this project. We have operations live in South America, in Chile, in Argentina, in Europe, in Spain and Portugal, in Africa, in Kenya and Uganda, and also in India, in both the north and south of India, which is almost like a continent all by itself. So that's just the beginning. So far, close to, as of today, maybe we'll cross that mark tomorrow, literally tomorrow, 1,498,000 people have signed up. And it's also pretty amazing to say that the World app, which is the software that allows people to use the Worldcoin network on their phones, has become the #1 crypto app in Portugal, which is a country that's really ahead of the curve in crypto and Web3 adoption in Europe and in the world. So that's a very nice signal. And what are they doing with this app? So we have three principal pillars. The World app, as I was mentioning, which enables payment, purchases, and transfers globally using the Worldcoin token, digital assets, and traditional currencies. Worldcoin, which is this first token to be globally and freely distributed to people for both utility and future governance, just for the fact of becoming or being a unique individual. So everyone who signs up gets 25 shares of Worldcoin just for signing up. And what this is kind of all predicated on is the technology behind World ID, which is our privacy preserving proof of personhood protocol. That's a mouthful, PPPOPP. But I've really come to love that acronym because it really summarizes what we're creating with World ID, which is a way to verify one's unique humanity without compromising one's privacy or traditional identity. So this is something that can supersede, circumvent the need for KYC. And for billions of people on Earth, KYC is unavailable. Why is that? Well, I'm speaking about refugees. I'm speaking about folks who live in countries where the government doesn't issue proper identification. I'm speaking about the people who are experiencing extreme poverty and don't have an address, and who up until now have been excluded from the digital economy because they cannot pass KYC. So with our technology, which is both all of these softwares that I've mentioned, as well as a hardware device that we call the Orb, that allows people to verify that they are a unique individual just once and receive in exchange the cryptographic hash key to their World app wallet, and also which includes their World ID. We are on a mission to first and foremost serve those people. But there's an incredible array of benefits that apply to all people around the world. So it's not just for the people who can't pass KYC. It's not just for the very poor. It's for everyone, because all of a sudden we've come into an era, as I'm sure everyone in the audience is talking about when they're not listening to these wonderful presentations, where it's become very difficult to know who's a person, who's a bot, who's a dog on the internet. And World ID solves this. It's proof of personhood. It's proof that you are interacting with a unique human being. And we envision this and are beginning to implement this as an identity layer on the Ethereum network. So here's some of what we're up against. All of a sudden, LLMs are passing what has, in the history of computing, been known as the Turing test with flying colors. The Turing test refers to this idea proposed by a man that many call the father of computing, Alan Turing, that says, if you can have a conversation with a machine and not know that it's a machine, that's when it's achieved, intelligence. And we're at that point, guys, as of 2022. And really, now that we're here in 2023, there's no denying that large learning models are able to have natural language conversations, provide incredible answers, synthesize incredible answers. I highly encourage everyone here to experiment with the OpenAI tools and the others, just to, pilot this spaceship and get better at it, so that we can be the users as opposed to being the used. So, as these increasingly powerful models become available to individuals, they become more difficult to control. And it becomes even harder to know whether you're interacting with an authentic human being on the other side of the screen. So here's a little text on the Turing test, and this is where World ID comes in. So as we move further into this time, each of us, in order to establish this trust economy, and to really move into Web3, a decentralized web, where it's not all about centralized providers of information and services. We have the opportunity with World ID as a frontline solution to give people trust back. And what does this address in crypto and Web3 particularly? Well, I'm sure many of you heard about what happened recently with the Arbitrum airdrop. So Arbitrum is a leading layer 2. It's a wonderful service, wonderful product. And when they announced that they were releasing a token, many wallets were eligible, but many of those wallets, a large percentage, I think it was up to 40% of the wallets that were eligible, were duplicates run by the same people who had been anticipating that Arbitrum would announce an airdrop. And I'm not trying to single out Arbitrum. This has been an issue across the board with airdrops. We call that Sybil attacks. And a Sybil is essentially a duplicate account run by an actor who is sort of manipulating a network. And people who are dedicated to this will run thousands or tens of thousands of Sybil accounts. And when an airdrop comes, like it did with Arbitrum, they'll scoop up a very unfair share of the percentage of tokens available and then be able to manipulate the market. And we saw a crash. And again, this is not the first time. I think the Arbitrum team has done a really incredible and remarkable job managing the fallout from all of that. And yet this is where we can start to imagine how important it will be to have one human, one account. So World ID is a development layer that now the SDK has just been opened as a waitlist. And if any of you guys are really interested in getting access to the World ID SDK, get on our Discord. I'm the community manager. Send me a message and explain to me your project and your use case, and we can help to get you towards the front of that line. I can't promise immediate access, but I can make sure that your application is not lost in the thousands of applications that we've received. And so this can be integrated with any platform as an identity layer, as an attestation on a smart contract, and on the network in general. So I can make sure that your application is not lost in the thousands of applications that we've received. And so this can be integrated with any. All of a sudden, I'm getting a little feedback. So as we see here, there are different layers to ID and to what we call KYC. So it's, the top layer is identity verification. Who are you? And people can answer that however they want. Beneath that is authentication. Are you who you say you are? and this can lead to impersonation attacks. But then beneath all those other two is actual proof of personhood. Are you a human? Are you unique? Have you not done this 10,000 times before? And that gives us, you know, resistance to Sybil, and obviously, you know, it prepares us for an age where intelligence is no longer a discriminator of humanness, and where so-called bots or these LLMs can display intelligence. So, you know, this is really going to help the world in a number of ways. And one of the ways that I'm most excited about, especially in my work interfacing with the community, like I spend a lot of time chatting with our operators and users in Africa, in Asia, South America, and in corners of the globe that are not always traditionally considered the center of Web3 and the crypto world, or the economic world for that matter. And, you know, there's this potential for redistribution of wealth. Ultimately, one of the tools that Worldcoin can help to facilitate is a very few strings attached version of UBI. And it's going to have a vital role in counteracting what we've seen throughout our lifetimes, which is the concentration of the economic power in the hands of the very few. And this goes in the scope of individuals and also of nations. And, you know, to redistribute the wealth and give people what they need to survive and to thrive, no matter who they are, just for being human. It's kind of like in our Twitter spaces yesterday, head of growth, Tiago, used the word birthright to describe the Worldcoin mission. You know, and it's like the human birthright. And that's what we're aiming to give people back. Something that they've been denied for a long time. And, you know, talk about decentralization. This is decentralization at the core layer of what we do. And, you know, we're just getting started. So I'm just going to take a couple minutes more to show you guys some of the other things that World ID will do. Like it says here, advanced spam filtering by proving the provenance that, you know, a message is coming from a verified human. Suddenly your email inbox is a lot cleaner, and your Twitter timeline is a lot cleaner, and your Discord is a lot cleaner, and you can actually filter for what's real. And it also becomes a core layer of reputation systems. A lot of great crypto projects are building this idea of rep. And a lot of the decentralized social networks have this as a foundational principle. And so by preventing the creation of multiple accounts, we prevent that layer of sort of farming reputation that people can do when they have dozens or hundreds of Sybils. It's also crucial to governance. You know, in a DAO system, voting becomes really important, and voting by weight, you know, and having this kind of experimental liquid democracy that a lot of the best DAOs are using is compromised when Sybils are employed. So having proof of personhood solves for that. And it also opens the door for some really interesting use cases. So, you know, specifically quadratic voting. And so if your project is experimenting with things like they're using at Optimism's Citizens House, which I've been a part of, then you have the opportunity to add a layer of trust and reliability to that. Of course, it's crucial for authentication, you know, and prevention of identity theft, because if it's your identity and it's tied to a unique hash that belongs only to you, that's a lot more secure than even, you know, your credit card, or, you know, you could lose your wallet, like your physical wallet, and that has your identification, and someone can impersonate you. But with this is based on who you are, your own biometric data. That is very, very difficult, if not impossible, to impersonate. And then we come back to the equitable distribution of scarce resources, and that's where I'm going to leave it. You know, it's that Worldcoin is at the beginning of a very exciting time in our growth and our mission to give people who have been left out of the global economy a chance to get in. And so, you know, when we're successful, it will be at the scale of hundreds of millions, if not billions of people. So let's all work together to drive adoption of Web3. Let's build amazing things together. Please sign up for the SDK and stay tuned for the launch of Mainnet. And I will open up now for some questions. Thank you so much.
All right, thank you so much. That was very interesting. I just remembered that it's 12 a.m. at your time, right?
Yeah, after midnight.
Thank you for giving a speech, even though it's very late time there. Okay, so I got some questions online, but let me ask if you have any. Okay, we got question there. Okay. Give me 1 second.
Hello, can you hear me? Oh, right. Okay, thank you very much for a nice speech. So I have one question regarding the KYC. So you mentioned that there is some difficulty of doing KYC because many countries do not have official identity. However, in developed country, for example, in Japan, 50% of people actually have a NFC readable KYC, and in that world, in perspective like anti-money laundering and stuff, I think there's demand for people to actually have their wallet ID KYC, and from Worldcoin's perspective, do you plan to integrate your ID with the actual official KYC, and how do you view your Worldcoin to be actually used for the actual identification in more developed countries?
That's a great question. So as I was mentioning, it's kind of like an integratable layer. So say in Kenya, where we're active right now, we're working with the government to add another layer to the M-Pesa system that they have there, which is their version of a digital identity service. And also in India, where we're active, they have the Aadhaar, which is a digital identification KYC. And so World ID just becomes like a badge within those systems that proves uniqueness and adds another layer of reliability, Sybil resistance, and seamlessness and interoperability. So say in Japan, if the government wanted to bring its digital ID service to scale and to facilitate frictionless transactions, it could integrate with the World app and integrate with World ID. And likewise for us, we can add it as a layer, and we have a really deep relationship with the governments of the countries where we work.
Okay, thank you very much. It's very clear.
Thank you so much for your question and answers. So we got actually some questions, but we are kind of running out of time. So let me choose one question. So, okay, the question will be, when will the service start in Japan? That's a question for you.
That's a great question. And the easy answer is soon. I'm sure that it's something that all of us in Web3 get used to hearing a lot, soon with 10 O's. What I can say for sure is that I myself will be in Tokyo next week. And we'll be at ETH Pragma on Thursday. And then we will be issuing World IDs. So we will be using the orb and scanning people's eyes and then deleting those scans and giving them their world ID while preserving their privacy all weekend long, and with a really, really beautiful booth. So if you guys are coming to ETHGlobal Tokyo, you can find me there. I'll be working to help to oversee the booth itself. And I'm really excited. It's going to be my first time in Japan.
Okay, that's very nice. Okay, I recommend one thing. You should eat a Japanese sushi. It's very different from other. Okay, so
I wasn't planning to. No, I'm just kidding. I cannot wait to eat it.
Okay. So, okay, thank you so much for joining us today. We'll have our next speaker from now on. So, thank you. Thank you, Samuel.
Thank you, everyone.
Okay, thank you.
It's such a pleasure.
Thank you so much.
Follow me at Orbman, follow Worldcoin, and find me on the Worldcoin Discord.
Okay, that was Worldcoin from Jason. And now, Samuel.
はい。じゃあちょっとですね、日本語でご案内。はい。ちょっと今までオンラインの登壇が続いたんですけれども、ここからですね、オフラインでのリアルでの登壇がちょっと続きます。またちょっと先ほどとは変わった形になりますので、ちょっとよりリラックスして、はい、臨んでもらえればなと思います。で、ネクストセッションのタイコなんですけれども、ちょっと冒頭にもご案内したんですが、タイコさんがホストとしてですね、イースグローバル東京のアフターパーティーをアキンドとしてもサポートさせていただいております。こちら4月16日、イース東京グローバルが終わった直後ですね、もう本当に直後のアフターパーティー、日本名で虎ノ門横丁ハッカー祭りというような形でやろうと思ってますので、はい、皆さんこちらもチェックしてみてください。Okay, thank you so much. Are you ready, Dave?
Yes, I am.
Okay, じゃあ、so please presentation, go ahead.
All right, konnichiwa. What's up, everyone? I'm super excited to be here in Tokyo. Yeah, it's great to be here and to meet all of you builders. Like, we really want to help you guys out just to build on Ethereum, essentially, because Ethereum's awesome. So, I'm going to be talking about Taiko, which is a ZK rollup. It's kind of an interesting one, and yeah, let's just get right into it. So the topics of discussion that I'll go through is, first I'll just give a background on Taiko. I'll explain like what are we in terms of where we're at right now, and I'll also talk about where we're going with our protocol. All right, so a little bit of a background on Taiko. So we are scaling Ethereum with a type 1 ZK EVM. Does anyone know what the ZK EVM types are by any chance? You can like raise your hand if you do, but maybe not. Okay. Cool. So basically, ZK EVMs can be classified into different types based on how compatible they are with Ethereum, right? So we are a type 1 ZK EVM, which means that we are the most compatible with Ethereum. It's actually considered Ethereum equivalent. So we'll talk about that a little bit more. The ZK EVM effort is a community one, actually. We work with the Ethereum Foundation's privacy and scaling team, along with Scroll, on building the ZK EVM circuits library. And this is to be able to prove Ethereum blocks as they are today. A little bit more background. We have several team members that come from Loopring, where they built the first ZK rollup on Ethereum. So we definitely have a lot of experience with rollups. We have around 25 people now, and we'll have 20 here in Tokyo, actually. So come say hi at like the ETH Tokyo event. We're down to like chill and just talk. Yeah. So a little bit more about us. Like I said, we are a type 1 ZK EVM. Another interesting aspect is we are totally open source and MIT licensed. So that's really everything. Like our protocol, all of the smart contracts, everything is on our GitHub for you to contribute to and read about our protocol design. That also kind of implies that we are a community developed and driven project. There's no like permissions in using Taiko. There's no permission to block proposer. There's no permission to prover. Anybody can run the Taiko network, propose blocks, prove blocks. It's not like owned by anyone. We have 55,000 community members on Discord. And our last testnet, we had 2,000 people running the node software and proposing blocks, and we had 140 unique provers in this testnet. So we had an Alpha 1 testnet where we had block proposing that anybody could do. In the Alpha 2 testnet, we had proving that anybody can do, but a single proposer. And in Alpha 3, we have some other stuff, which I'll go over. Okay, so I want to get back to this Ethereum equivalent thing, because I know that we've been talking a lot about like roll-ups and scaling, and like it's a lot to go through. So let me try to put it in this perspective, right? So if you look at this chart here, there's like, you can go from type 1 to like type 4. This is kind of like, Vitalik wrote a post about classifying ZK EVM types, where you can kind of your ZK EVM can be on a spectrum of having high compatibility or having like higher prover performance. So we choose to like maximize compatibility and not change anything about the rollup that would make it easier to generate faster proofs. So an example of like maybe one thing that could generate faster proofs is if you use like a custom VM, right? Like zksync or something like that. But we still use the EVM. We still use the same hash kchak 256 hash function. We use the same Merkle-Patricia tree data structure. In fact, we just use Geth, which is a Ethereum execution client, and we fork that library and just or that code, and we just make very small changes to it for our protocol. But when you use Taiko, it essentially just looks like you're using Ethereum because it's this type 1. So this next point I have here is like, what is a rollup, right? And I think it's an interesting question, like what is it really? And I would say that it's kind of a state machine, just like Ethereum is, right? Like Ethereum is a state machine. A rollup is also a state machine. You're just going from one state to another state, and to get from one state to another state, the inputs are some transactions, right, to define the next state. And for our, the state transition on Taiko is the same as Ethereum. In the Ethereum yellow paper, there are validity rules, which define the state transition function on Ethereum, and we use that same function and validity rules on Taiko. So yeah, also like, a rollup is something that you can build from some base layer, right? So we rely on Ethereum as the base layer for the data availability. So you can always build Taiko state just by examining the contract which is deployed on Ethereum. Yeah, and like I said before, we just reuse a Geth execution client. Everything's the same: gas costs, state trees, the hash function. One really cool thing about this as well is like, if you think about how bridging would work on a really like elegant protocol like this, you can literally just use Merkle proofs. So like if you're on, let's say, Ethereum, or you're on Taiko, all you really need to do if you want to bridge some data over from Ethereum to Taiko is to just present a Merkle proof that that state was included on the source chain. And because the destination chain, in this case it would be Taiko, uses the Merkle-Patricia tree to create blocks, it's simply just verifying a Merkle proof to send a message. So it's like, I don't like the word trustless, but it's an extremely trust-minimized bridge where you don't rely on anyone. You can just use Merkle proofs yourself, call an Ethereum node, just say get proof, like ETH get proof, present the Merkle proof to Taiko, and then you can securely bridge over some type of data or funds. Yeah, and again, like Taiko is like actually more of like a platform for building. We don't even consider a bridge like a part of the Taiko protocol. A bridge is just like an application that's built on top of Taiko, and anyone can come and build a different bridge. Okay, overview of current protocol design. So I'm just gonna like kind of breeze through this, but kind of show like you know how the protocol works, right? So like down here you have the users, and they're submitting transactions on the roll-up, right? Like the roll-up is just all of these nodes. Everyone is running nodes, and people are submitting transactions to that mempool. And then also, actors within Taiko can run a version of the node software, which makes them a proposer. So they can select transactions out of that mempool and propose them to the layer 1 smart contract, which governs like what the state of Taiko is. So they go ahead and they propose a block. There's like these slots that exist on the layer 1 contract. So you can see here in blue, this is a block which is proposed, right? And you see here, I put in parentheses at the top that it's deterministic. I know instant finality is like also a common word, but basically what I'm trying to say here is when you propose a list of transactions to the layer 1 contract, we have very well-defined validity rules to compute the state transition for the rollup. And we just derived that from Ethereum. So as soon as you get the list of transactions and it's proposed, anybody can compute the rollup's next state. So you can just move on immediately. You don't even need to wait for a proof. So that's why we kind of prioritize compatibility a lot, because we see proof generation time kind of going down, and people can still continue on the rollup because you can deterministically get the next state of the rollup, you know, right away. All right, yeah, so you propose the block, and then prove a block. Yeah, so proving a block is just proving that you went from one state to the next state, you know, and everything was done in a valid way. So you need to present like a validity proof or a snark. You present that to the contract, and this block can become proven, right? But keep in mind, this is just proving one state transition to another one. But you don't know if the parent is proven yet, right? Which is why we have a third state, which is verified. So verified is like when all of the parents from Genesis are proven to have had valid state transitions, then you know that the current block has had like a valid proof for you to move forward. And this is like you know, some of the, like I said, you can continue on the roll up without a proof, but you might want to have a proof for things like bridging out of the roll up. Yeah, so constructing the roll up state, I kind of touched on this earlier. It's like right when that transaction list is proposed, you can just start building Taiko's state like immediately. No need to wait for a proof. Yeah. This is just kind of like an overview of what I just went through, like the steps. Okay, I want to talk a little bit about where Taiko is going with the Alpha 3 testnet. So we're simplifying the protocol with some major optimizations and features. So like I said, when you propose some transactions and we do some validity checks to figure out what the next state of the rollup is going to be, we're moving a lot of that logic out of like layer 1 and just putting that into like zero knowledge proofs that the nodes can do. And this will make the fees a little bit cheaper for users and simplify the protocol a little bit. We're also going to enable EIP 1559 on the L2. And we have this, you know, one thing I didn't touch upon like as much is how like Taiko is like this fully decentralized, right? Like anyone can prove blocks. There's no centralized sequencer. Anyone can propose blocks. It makes for a really interesting tokenomics kind of problem for us, right? Like kind of a fun challenge actually. So, you know, one of the things that's coming next in our next testnet are these EIP 1559 inspired fee structure for charging proposers and also giving rewards for people who generate proofs on Taiko. We're going to apply some lessons learned from our last testnet. like on contract upgradability. And I put one other interesting point here, which is like, does prover decentralization matter? And I think it's I think it's an interesting question where it might not matter as much as having permissionless prover network, because the real important part of the decentralization is kind of like on the consensus layer, which we rely on Ethereum for that. On the proving layer, it might be okay if there's just a few entities but anyone can join and they can go ahead and like prove blocks. We're also going to have some more circuits done, get closer on the roadmap of the zkVM circuits, and moved our code base to using Foundry. Long term, the community needs to finish the circuits to prove Ethereum blocks as they are today. And like I said, we're kind of working collaboratively with that. I put enshrined rollup here just because I feel like Taiko would probably be the best candidate for that as a type 1 zkEVM. EIP 4844, which is proto-dank sharding, is something that's exciting for all of the rollups. And then also we're going to make some progress on these rollup training wheels. And if you don't know what that is, you can just Google like rollup training wheels. There's a post by Vitalik on this, on like how we can make rollups more mature and more secure. So we're going to try to make improvements on that as well over the long run. Let's see here. Resources to build on Taiko. So yeah, I know a lot of you are here for the ETHGlobal Tokyo event, and I'm sorry to say that dApp development on Taiko is very boring because it's literally the same as just building on Ethereum. So any Ethereum tutorial, like no questions asked. You don't need to be like, oh, but like, do I need to change this? Like, can I use the transfer function, or can I use will the block hash like be based on like a Merkle Patricia tree? It's just the exact same. So you can just develop like you're developing for Ethereum, change the RPC like you would for like a testnet or something, and you're good to go. There's several guides available at taiko.xyz on how you can start building here. I also made like, you can like go to my GitHub repo. This is called like dApp slaps. And if you just click this blue button, this one click, you'll have like a dApp, which you can just start like hacking on. I'm going to try to make this support like a lot of networks, hopefully, before ETHGlobal Tokyo starts. But you could think of this as like, this dropdown could have like Taiko, Optimism, Scroll, like anything really, right? All these EVM equivalent chains. But yeah, I made this. Hopefully it helps you guys to just get started building in like one click, I guess. And you can check that out. And then also feel free to come help build Taiko itself as well. Like you can come look at our repo. Like I said, we're fully open source MIT licensed. We have a contributing guide, and we are happy to collaborate. And then yeah, we have like 20K USD in prizes for ETHGlobal Tokyo. We're like one of the major sponsors. So yeah, come get some money. Yeah, here's some QR codes. You can follow us on Twitter, read the docs. These are the slides. And yeah, thank you so much. Open for any kind of questions.
All right, thank you so much. It was very fun. So if you guys have any question, please raise your hand. I actually got 2 questions online too. So first one is, actually this is not question, it's more like a requesting, but he or she wants to see your shoulders, the pictures.
Oh, this?
Yeah.
All right. Yeah.
There's a camera right there. Maybe, yeah, people
right.
can check it.
Yeah.
I have a question about that. Why is Taiko? I mean, like, why did you name your project Taiko? Is it like Japanese Taiko or just?
Yeah, there's like a Chinese story as well, but it's like a combination. It is related to a drum, but there's like I can't remember exactly what the quote is, but it's based in like the beat of a drum, and also just kind of like just doing our best effort to like kind of like complete something that's really ambitious and difficult. So yeah,
that's very nice. Thank you. So another question that we have for you is, what is the important point of choosing roll apps? There's so many types of roll apps or layer 2, and it's getting more complicated. That's the question.
Yeah, so the most important choice, it depends on what you're trying to do. If you're just at a hackathon and you want money, just deploy to like whatever rollups and do that. But in terms of like user security, which is very important for everyone, right? You need to you need to be careful about the security risks. There's like so many different ones. Like it would be hard to go through all of them. But like, let's say you even had like perfect ZK EVM circuits, right? If there's a bug in your client, in your execution client, like you're using Geth or something like that, if there's a bug in that, you're just proving something invalid anyways. Like that's one bug that could come up. Another bug is just the ZK EVM circuits are broken. So like, you know, you might need to have like some diversity on the proof system, diversity on the execution clients. There's all these security risks. So like, I mean, I don't mean to like just shill Taiko or anything, but I would stay on the side of high compatibility because it'll give you easier time as a developer, but it'll also give you more like a better feeling of trust that something won't go wrong. Because otherwise, you need to make all of these considerations like, will this work in the way that I expect it to? So I would say try to stay towards, just my opinion, like more EVM equivalent. Maybe Ethereum equivalent is the best. That would be kind of my opinion on it.
Nice, thank you so much. I have one question. I mean, not me, but like there's a question online. So Taiko is type 1 ZK EVM feathers. Other types of layer 2 are also available. Do you think they will coexist, or will they eventually be battled? That's a question.
Wait, there will eventually be a what?
Eventually be a battle.
A battle.
Yeah.
I see. I feel that there will. I feel that we're going to migrate more towards EVM compatibility or Ethereum equivalent kind of things. And the reason why I feel that way is if you look around, you'll see there's so much progress. Even if you don't like the EVM, like I know there's things to complain about the EVM, but even you can't deny that so much work is being done on Solidity, the EVM, like things like Foundry. I think a lot of work is being like done to support this kind of developer community on Ethereum. So I would kind of bet on the EVM compatible side, and I do see for some reason like there being like multiple rollups existing. Like it's difficult for me to imagine just one being there because all the teams are going to be trying hard, and I can imagine there being multiple ones, which makes all of this cross rollup communication work really interesting too.
All right, thank you so much. We got another question. Taiko members are from looping the same ZK rollups. Why was Taiko developed?
Yes. So the reason for Taiko being developed is because we wanted to make like a general purpose ZK rollup, and Loopring was kind of set out to be more of like an app-specific ZK rollup. So I believe at Loopring, they're kind of maybe going more for this like app-specific rollup or layer 3 path, where Taiko's focusing more on a general ZK rollup for people to use.
I see. Thank you so much. So
Okay.
is there any other questions here? If not, then yep. Okay. どこ?
I have one question. What kind of dApps do you want on Taiko?
All of the dApps.
All of that.
No, but what's I think bridging is really interesting. Like also, but really like all kinds of dApps. We want people to just come to it, and you don't need to think like it's a lot of friction to come to Taiko, because if you just develop on Ethereum, like you just develop on Sepolia testnet, migrating to Taiko is simply just changing one URL and then you're there. So I would just think of let's develop for Ethereum, and then Taiko will just help Ethereum scale. So, but really, it's just let's just develop on Ethereum and what's cool for Ethereum. And again, like I think bridges are cool in this rollup space. I'm just gonna give a little bit of an extended answer because we have like these totally decentralized nodes and like provers that people can run, kind of like on Ethereum. We hope to see like some progress in making it easy for the community to just run nodes. They can like earn some money. They can become like a prover. Maybe it'll be like this like new like mining era for like generating proofs. So I think improving that software is another type of application for Taiko.
Thank you.
Yes,
very much.
thank you.
Thank you for your question and your answers. Thank you so much. Any other questions? Okay, so thank you so much for your speech. And I think it was the first in-person speech today. Yeah, that was very fun. Thank you so much.
Okay, arigatou gozaimasu.
Arigatou gozaimasu.
Thank you so much. はい、じゃあここからですね、ちょっと10分ほど休憩の時間を取りたいと思いますので、4時5分からまたスタートしたいと思います。はい、じゃあ休憩となりますのでどうぞお手洗いなど行ってください。ここ BGM 流してもらっていいですか。
皆様、間もなく始まりますので、お席の方にお戻りいただければと思います。間もなく始まります。
はい、次のユーマプロトコルのセッションが始まりますので、お席の方にお戻りください。これ来てないですよね、向こうの。どうぞお席の方にお戻りください。じゃあ高橋さん。まだ来てな。あ、来ました来ました来ました。
So are you ready, Clayton? Nice. So next speaker will be Clayton from UMA. Yuma.
Thank you.
Okay, go ahead. It's your presentation time now.
All right. Can everyone hear me okay?
Yes.
So, perfect.
Yay.
So my name is Clayton Roche. I'm the comms and community lead at UMA, or UMA Protocol. UMA is Web3's decentralized oracle, and we'll talk more about what that means. So I'll just preface this by saying I'm not a developer, but I'm really passionate about what we're building and excited to share it with you all today. But if you ask me extremely complex developer questions, I'll defer to someone else in the audience. I've also used Google Translate here, so if there are obvious mistakes, that is why. So the first thing I'm going to talk about is why your data must be decentralized, your data source specifically. I'm just going to quickly flip through these. I don't know how they got into my presentation, but you can understand maybe why they would be there. Whenever you have points of centralization with your smart contracts, you're introducing a wider attack surface, basically. And there are just so many cases lately, examples of why this is a problem. Decentralization is important. So at UMA, we believe in being uncensorable and being unstoppable. So how many people here are familiar with UMA already? Okay, got a good handful. How many people are familiar with Chainlink? Everybody. Yeah, very good. Okay, so this is what's behind Chainlink. This is the ETHUSD price feed at Chainlink. And here are all of the nodes of their decentralized node network. You can sort of see who they are. You can see their logos. You can look up some of these teams on LinkedIn. Chainlink may not use these words, but I would use these words to say that Chainlink is secured by reputation, and it's backed up by a multisig. So anything that happens on Chainlink can be rewound or intercepted by a multisig. So there are fewer than 20 people, I think, in the world. It might even be a 6 minimum, I think, that need to sign a multisig in order to intercept a piece of data from Chainlink. This is becoming more and more concerning to me as my government in particular is going after more and more individuals. This is what's behind UMA. This is who is behind UMA. So you can go into Google and type in 0x0c6f9 and you'd find nothing. There are no logos of who's behind UMA, who's securing UMA. It's all of the token holders and the voters. UMA is secured by game theory. So the nodes that I showed you on Chainlink, all of those nodes applied to be to participate in Chainlink's network. With UMA, anyone can buy a token. It's completely permissionless. And by owning the token, you're helping to secure the network. So what does an oracle actually do? I like to go back to kind of first principles. So in the developer crowd, I'm sure that everyone sort of has an answer for what an oracle does. I like to think of it that the whole point of blockchains, the reason blockchains are cool is because it's very difficult to edit the data that's on them. The process of mining is this big complicated process just so we can all agree on which pieces of data should be changed, which account balances should be changed. If you want to use data that's already on chain, that's very easy for your smart contract to get. That's already gone through this system, this filter, to go on chain. Most data that you want to use is not already on chain. If you want to do an account balance or a timestamp, that's easy, right? But if you want to do lending and borrowing that involves prices, if you want to do any complex markets or derivatives, all of that data needs to be put on chain a different way. And you also need to trust it against manipulation. So if you, the developer, is, let's, for example, say putting the price of an asset on chain manually, you might be right, you might be entering the correct price, but you are, of course, the point of centralization. So this is where oracles come in. They are, to me, kind of the added pen that you can use after a block has been mined to add in a piece of data. So you're going to need an oracle if you want to build any of these sort of boring finance things, options and futures, cross-chain data, NFT floor prices, complex computations. You can do off-chain and then push them back on-chain using an oracle, API data feeds, derivatives, stablecoins, so on. There's also kind of these sexier things. You've got political scandals, sports blunders, legal outcomes, international catastrophes, betting and gambling, gaming and incentives. One of the recent political ones that UMA secured, although it didn't end up sort of happening, was will Donald Trump smile in his mugshot when he's arrested? It turns out they didn't release a mugshot of Donald Trump, sadly, but that was a fun market. So if it matters to people, we probably want to put it on chain one day. I think that we're realizing this as a space. In DeFi generally, most of the time we're talking about price feed. But that's starting to change. And UMA in particular is well suited for flexibility, and that's what allows developers to build kind of unusual things. If you want to build something other than a lending and borrowing protocol or an options or futures contracts, UMA can get very useful for this because you can use it to answer very specific questions. UMA is an optimistic oracle. It is not UMA. So what goes into optimistic oracles? So I'd like to play a little game here. Hopefully someone can play along. Does anyone here have a 1,000 yen note with them? Anybody at all? Yeah, you're nodding. Can you pull it out? Anyone that wants to play the game, pull out their 1,000 yen note. Can I see it? Oh, you don't have it with you in your pocket. You've got one. Thank you very much. Okay, very good. So here's what goes into an optimistic oracle. It's an assertion. And when you make an assertion, you're saying this thing is true. So, young lady here, what is your name? Rhea. Thank you, Rhea. So I'm going to make an assertion. Rhea is in Tokyo. There is the second piece that comes with this is a dispute window. And so you are a potential disputer with your 1,000 yen note, okay? And so I say, Rhea is in Tokyo, and I say that statement and I put up my bond, right? So I have an incentive to be truthful here. I say, Rhea is in Tokyo. Now I'm going to open a 5-second dispute window for anyone that might want to dispute if they have the bond amount. You shouldn't dispute. Okay, now I'm going to do another one. So the 5 seconds go by. Hopefully he's not disputing unless he wants to give me his 1,000 yen note. Okay. So now I'm going to go ahead and make another assertion. Rhea is in the United States. Here's the dispute window. We have a dispute. We have 3 disputes. All right, but one of them was bonded. Okay. So somebody's disputed that claim, right? And what's important about this is I put up a prize for someone to dispute me, right? And he put up a prize, or a bond, essentially, to make sure that he's not just wasting our time. So now, what happens in that occasion is everybody here gets to vote. Let's assume you're UMA token holders. So this statement is true or false. If you think it's true, raise your hand. Rhea is in the United States. If you think it's false, raise your hand. Rhea is in the United States. Okay, we have 100%. So what that does, and the way that UMA works, is this bond that I've put up, I've now lost. If someone wants to run it over to this fellow here who volunteered, I would appreciate that. No, I'm serious, but I'm on a chain here. So this bond is now lost. This goes to the fellow that disputed me. What's cool about this, so that would be the unhappy path. We did a dispute resolution, everyone here voted, and that determined who got the prize. That data then would not go on chain. Rhea is not in the United States, and so that data would be thrown out. But what's going to happen, if you can just sort of see the game theory from this, I'm not going to come on and lie. In fact, I'm going to come on and invest some time into making sure what I'm saying is accurate, because otherwise I'm giving away my money. And just the same, sorry, what's your name? Chris back here is not going to just dispute things silly. Well, he will right at first. But after he gives me the money, right, he'll stop doing that. And that's exactly why UMA operates particularly well, because it has this dispute resolution system that just doesn't need to be used very much because of the way the game theory is designed. So I'm going to take you through a few videos here that are going to demonstrate the same thing, if they will load. Okay, so here's an example of kind of how the Oracle operates. You can put in assertions. The price of Oracle was below $87. This Wi-Fi is funny. Okay, so it puts in these different assertions, right? I think we get the idea there. This money was transferred. CryptoPunk 181 didn't pay royalties on the last transfer. All these different statements of truth can be put into the Oracle. This is even the special speaker internet that I'm using here. Okay, so these different statements of truth can be put into the Oracle. And sorry, next slide. There we go. Essentially, actually, I'm just going to skip the videos. That's not operating properly. Essentially, humans and robots can watch this data that's coming in. And they are. So UMA has been alive for 2.5 years, has secured billions of dollars in markets over those 2.5 years. Right now, its TVL is $76 million. It can secure a range of interesting things. So we have prediction markets. The Trump smiling thing is an example of one of those prediction market questions. DeFi insurance. UMA secures Sherlock and Cozy. You might have heard those names recently because they paid out on the Euler exploit. Optimistic governance. There's someone in the audience that's asking me about that today. OSNAP is a product that we released. And essentially what that does is it takes snapshot outcomes and pushes them on-chain trustlessly. So if you've ever used Snapshot, if you've ever calibrated it to enable your token holders to vote, you know that you can specify all these really cool things like LP tokens and tokens on other chains. They can all participate in a governance vote. You can use UMA to push that vote on chain. And what that does is it sidesteps multisigs. It is kind of absurd to me how many DAOs out there today are still using multisigs. And we sort of ignore that. It's sort of like this thing that we pretend isn't happening right up until a team disagrees with a DAO and overrules them and does something else than was voted on. So as a developer, if you're interested in building on UMA, you're interested in building something using Web3's decentralized Oracle, and you're interested in maybe building something new that uses a different type of data than price feeds, would love to chat with you and would love for you to check out UMA. Here's just an example of what you'll find on our website. We have different modules that you can check out: governance, prediction markets, cross-chain communication. UMA right now secures a cross.2, which is a cross-chain bridge. It does several million in volume a day. And it's the same kind of idea where you're using UMA's Oracle to validate that the transactions and the rebates happened as per expectation. So we are sponsoring ETHGlobal, 10,000 in prizes. So please come check out our booth and chat with us. You can follow me on Twitter here at Token Architect. And if you're not risk averse, you can scan the QR code to get you there too. And then here are just kind of our links. You can go to docs.uma.xyz or discord.uma.xyz. Obviously the docs, well, you know what both of those things do. Yeah, that's actually the sum of my presentation. I would love to hear questions. I'd love to hear if there's any gaps in kind of your understanding of an optimistic oracle and why I think they're the future of data provision in Web3.
Thank you so much for your speech. So if you guys have any question, please raise your hand. Okay.
Thank you for a great presentation today. I have one question for you. If developers use UMA as production environment, what kind of fee do we have to pay?
So there's no fee to use the protocol in the sense of paying a service fee to the protocol. There's no like you pay with link tokens to Chainlink. We don't have that. What you do have though is essentially the disputer bond. You need to put up that dispute bond that somebody could dispute you with. Now, as long as your data is good, you won't lose that dispute bond, right? However, there's another way to use UMA where you aren't the proposer. And this just sort of depends on how you need to use UMA. So let's say you have an API, you already know your data, you're confident in it, and you just want that API put on chain, and you want credible neutrality. You would propose the data, you would put up the bond, you would get the bond back each time, and that's it. So it's essentially free, it's just the gas cost to do that. If, however, you want someone else proposing the data, which can be important for regulatory reasons, you would need to provide a proposal bond, essentially an incentive that you would pay someone else for proposing that data. Does that answer the question?
Mm-hmm. Okay, got it, thank you.
Sure.
All right, thank you so much for your question and your answers. So any other questions? If there are no question, I have a question from online. So the question is, we plan to utilize UMA in our ETHGlobal hackathon. What kind of product would you like to see made with UMA?
Sure. So, yeah, that's a great question. So UMA is sponsoring the hackathon, of course, and so we'll have a booth there. The thing that I'm most passionate about, and there is a team working on this now called Checky, is news validation. Essentially, what UMA is a bounty for people to catch you lying. And so, like, something that we need more in the world of right now is truth that you can actually trust, information that you can trust about the rest of the world. And this is something that's very close to my heart because it gets to just the heart of democracy, right? The ability for us to know what's going on elsewhere in the world and to believe it and to trust it. So that's really the thing that's most interesting to me is news validation. It's not necessarily a straightforward project, right? Because to say whether something is true or false in terms of describing a news event is a complicated question to ask and answer. But I do think that we can make progress on that, and it's the area that I'm most interested in seeing built.
Okay, that's very nice. So that's the way, like, we can earn your prize, right?
Well, I'm not the only one evaluating.
Okay.
Anything that surprises me is probably going to get my attention. I like new things.
Yeah, thanks for the presentation. Is there any incentive for people to vote, like, honestly? It just seems like we could collude and then steal
Right. Yes, there is. So presently, this is going to change in about a week, but presently the way that UMA works is the value that UMA can secure must be less than half the total value of the market cap, which means that you need to have more money on the line than somebody could actually bribe you with, that it would be worth bribing you to steal. That was very confusing. Basically, you wouldn't spend $10 to steal $8. That's the way that it's set up. There is also an incentive to vote correctly because as a voter, if you stake your tokens, and if you don't vote with what's called the Schelling point, which is just the majority vote, you'll lose a small portion of your staked tokens. which over time would add up. It's not too punishing in any one vote. So there's a vote by vote incentive to vote correctly, and then there's also just the global sense that if you hold the UMA token and you were to collude and lie, you would expect your token to go to zero, and you can't secure more value than the value of the token for that reason. One comment I'll make is we're about to introduce an escalation manager, which will change kind of that formula, where there's going to be steps of escalations that you can do, which essentially will allow you to escalate to your own token if you ever need to get there. And that'll allow UMA to secure more value. But that's not been officially announced yet. I'm still working on the blog post. Any other questions?
Thank you very much. It's kind of related to the former question, but can you elaborate on how specifically the dispute bond works? I mean, is it like staking ETH in Ethereum, or just like a deposit of fiat?
Yeah, it is a bit like that. So when there is an assertion, so Donald Trump was smiling in the mugshot, for example. Let's just say that was the assertion. There's this 2-hour counter, in this case, 2-hour window, and you will submit, I think, $1,000 dispute bond, and there's a dispute reward associated with that as well, or proposer reward. So anyone through the UI can do that, and it's either going to be priced in USDC or in ETH right now. There's options for that in the future. But yeah, it's essentially that you post it, and if you were to, you post an assertion, you put up this bond, as long as no one disputes you, you just get it back. If you do dispute, if you're the person that disputes, let's say Chris disputes that Ray is in Tokyo, your money will stay locked up until that resolves, which is a maximum of 72 hours. And at which point, depending on which way it went, true or false, that amount would get pushed to kind of whoever was on the right side of it. Does that address your question?
Yeah. Thank you very much.
Thank you.
Thank you so much for your question and your answers. We actually have one more question online, but we are kind of running out of the time, so maybe he should DM you, right?
Sure. Yeah,
okay.
Happy to DM. Yep.
All right. Thank you so much for your presentation and Q&A, and it was very fun. So thank you.
Thanks,
it was Clayton from UMA.
Thank you, Clayton.
All right. So next speaker will be Alex from Connext. Are you ready? All right, please. All right, you got your mic?
One moment.
Okay, enjoy your speech.
Hello. Let this load. It's not loading. One sec. You think so?
今ちょっと Wi-Fi に問題がありまして少し遅くなっております。ご迷惑をおかけいたします。
Yeah, I'll try it. Zeus?
Yes.
Okay. Could not join.
はい、今からお話しいただくコネクストさんのビルダーズワークショップをですね、今度の水曜日に開催する予定ですので、こちらもアキンドの方でサポートさせていただいているようなイベントを行う予定なので、今日コネクストのお話を聞いて興味を持った方はぜひこちらもご参加いただけると嬉しいなと思っております。はい、渋谷で行う予定ですので、ぜひご参加いただけると嬉しいなと思っております。
Some technical difficulties. Of course this happens. There we go. All right, we made it work. All right, I'm Alex. I'm the head of product at Connext. Nice to meet you all. So I'm going to talk about chain abstraction and a better user experience for scaling to more users, ideally the next billion users. So first I'm going to talk about why this matters, what chain abstraction is, and then shill SKALE for a little bit. So Ethereum needs interoperability more than ever. We've been talking about interoperability for years, and this has been increasingly needed. If you look at TVL, this is on DeFi Llama. It's spread across 182 chains right now. We have new chains launching it feels like every week. The TVL has continued to fragment, and users are also fragmenting across chains. So we need a way to basically cohesively link this together and make it a more cohesive ecosystem. But when I look at this as a product person, I usually think okay, what does this mean actually in terms of users? How many people are actually using this? What does this represent? So there's a few ways to look at this, and there's research. I asked ChatGPT because it's fun, and I've been just doing that more. And so in March, there was 2.63 million daily active addresses on Ethereum. But, and it says the average user has multiple addresses, so this is actually far less users. It's kind of interesting in Web3 when we look at daily active users, we typically look at addresses, but this is definitely inflated because we know, we all have multiple wallets. There's also smart contracts. So the actual number of users is much smaller. And the reason this is important is we typically look at a chart like this, which is where are the users today? Which chains are they on? And so when we're building for users, a lot of times we think about how do we get more market share? And we're thinking about the existing users. But I think the more important chart is this one, which is there's 4.7 billion people online, and we have such a small piece of that. So a lot of times we talk about taking more market share, like how do we get more of the existing pie versus growing the pie. And I think really scaling to new users is a big thing of what we're focusing on and why interoperability is so important. So in order to scale these people, you have to realize most users don't care about infrastructure. We like it because we're technologists, we're nerds, we like talking about this stuff and using it, but most people don't want to actually interface with infrastructure. And they shouldn't have to. So in YouTube, right, if you go to use YouTube and you want to watch videos of cats, you'll just look up cats and you pick whatever the funniest video is. You'll watch it, you might watch another one. But when you're doing this, you're not thinking about what APIs are behind the scenes. Are they using AWS? Are they using my metadata for the ranking algorithm? You're just thinking about watching videos of cats. And so similarly, I think if we're going to scale really to more users, we need to start thinking in this mindset that most users will not want to think about actual blockchain infrastructure when they're using it. And so this is Aave. Aave is a great product, but it's too confusing for most users still. And part of that is the chain concept. So for example, say you want to lend money on Aave. Today you have to go, say you get your first $1,000 USDC on Ethereum, and you go and you see the best returns are on Polygon. How are you actually going to go lend money on Polygon? Well, today you actually have to leave Aave. You have to find a bridge your money to Polygon, find Matic to pay for gas, go back to Aave, and then initiate that lending loan. That is just not going to work for most users. It's far too complex. And this whole concept of being okay, I'm on Ethereum, now I'm on Optimism, now I'm on Polygon, It's too confusing for most users, and it's not going to allow us to scale and really grow that pie. Bridge UIs are also bad UX. This is actually our bridge. We're proud of it, but we don't view this as like a product that people enjoy using. People don't wake up and they say, oh, I can't wait to use a bridge UI, right? They're using this to get from point A to point B to do something new. And we really hope that this is a temporary, well, we know this will be a temporary solution, and it's not really our end game. So this is our product, the interface, but it's not really the core product. The core product is the underlying tech, and we hope that this goes away at some point. So this is where we talk about chain abstraction. So the key way to do this is start abstracting chains from the users. So obviously this is a nod to account abstraction, which is a huge part of this too. But chain abstraction is basically the idea that users don't have to consciously think about what chain they're on. So that same idea of I'm on Optimism, now I'm on Polygon. If we really want to scale to new users, we have to start abstracting that from the user experience. And so this is where I'll talk about Connext XCall. This is our core primitive that allows you to actually build chain abstraction into your application. XCall is basically similar to a call on one chain, except you can make calls across chains. So it's a core primitive. This is really our core product. And this is the interface on the right. So it allows you to just send messages and do callback functions as well across chains. So here. So similar with Aave, this is an example of what it could look like with XCall. So instead of the user having to say, OK, I'm going to switch chains and deposit, the user is on here Optimism, say they want to lend on Polygon. They will basically just click, OK, I'm going to lend on Polygon, and the application handles the rest. So here, as a developer, if you were going to set this up, you would deploy an XReceive contract on the destination chain. You call XCall, and it will actually interface with that. The user will receive their tokens in their position on Polygon, and they'll never actually have to leave Optimism. So for the user, it's much easier. They stay on the same chain the whole time, and you're actually building like a much more scalable user experience for people that are like newer to this infrastructure. So again, users similar to the cats thing, the user just uses the application, and they're not thinking about the actual chains. XCall allows you to unlock all of these chains with like a simple primitive. This is just showing our actual architecture. So we are a modular execution layer, and we have a liquidity network. So XCall basically is the endpoint that allows you to unlock all of these chains. What we do is we plug into the most secure trust minimized AMBs on every chain. So we connect to like Polygon's AMB, Optimism's AMB, and we allow you to basically get security out of the box with this simple primitive. And yeah, so there's a lot of opportunities for chain abstraction. These are just some of them: cross-chain zaps, cross-chain governance, gaming, but it could be really anything. So we invite you to definitely come ask us if you have any questions about building with this. We really want XCall to be, well, not even just XCall, but this idea of chain abstraction to be a core part of development to really help us like scale Ethereum to the next, ideally, billion users. And that's it. These are our docs if you want to check them out, or you can message me on Telegram or join our Discord. And yeah, that's it. If you have any questions.
Thank you so much for your speech. If you guys have any questions, please raise your hand. You have a question? No? Okay, I think, yeah, your presentation was so good that no one has. Okay. Maybe that wasn't too good then. Okay, please.
Hey, thanks for that, that talk. So when it comes to kind of dealing with the liquidity problem on these different chains, I'm curious how much like liquidity management is done, and also like maybe the delays that are associated with moving funds around, or am I maybe misunderstanding how this works?
So there's well, I guess what exactly do you mean by liquidity management?
I guess what I mean is like when you're talking about canonical tokens, which I'm assuming is the only thing that Connext uses, right?
We use canonical, yeah.
Yeah. like you can only have, they can only sort of get there through the canonical bridges, right? And so if they're not already there and there's a demand for that liquidity, how is Connext like handling that?
I guess I don't fully understand the question. Sorry. Yeah.
So like, okay, so if someone's bridging funds, for example, right, and it calls for a certain, like, how does Connext say, for example, we're out of liquidity if I try to bridge, 10 million or 100 million USDC on that UI? Like, what determines how much liquidity you have, I guess, is a different way to ask that question.
Sure. So we have a liquidity network. People can run nodes, and basically they allow for faster transactions. So they're basically fronting funds on the destination chain if there's liquidity. If there's not, then we actually send it through what we call slow path, which is through the actual underlying messaging bridges. And we will lock in mint, or ideally burn in mint if we've actually built that functionality with a certain token. But we have two paths. We have the liquidity network, which is just basically a latency feature. So you get your assets in 3 minutes versus going through the slow path, which is actually, we have a hub and spoke model where Ethereum connects with all of the different like L2s, and we'll aggregate Merkle roots and we'll send that through, and you'll receive your funds in about an hour. So we have both options really.
Cool, thank you.
Sure.
That answers it.
Yep.
All right, thank you so much. We got a question online here. So the question is Connect conceptually different from layer 0?
Yeah, so layer 0, there's a lot of different, obviously cross-chain protocols. So layer 0 is a messaging bridge, a messaging layer. The biggest difference is we think that layer 0 is a little bit more trusted. They have their own relayer and sequencer. And basically, what we do is we focus on the AMBs that are the most secure and trust minimized, but we're the modular execution layer. So we could, in theory, integrate with layer 0 as the messaging layer. It's just a different part of the stack. We focused on the core AMBs that we think are the most secure and trust minimized.
Okay, thank you so much.
Sure.
So is there any other questions? If not, then okay, that's it. So thank you so much for your speech, Alex.
Thank you.
Thank you. Thank you, Alex.
So the next speaker. Okay, next speaker is Fran from Superfluid.
Yeah, it's going to be. We are going to switch the channel. Yeah.
Okay. 皆さん、こんにちは。
こんにちは。
こんにちは。
これもしかしたら初めて日本語でのワークショップなので、結構言葉が出しにくいので、ちょっと最初から謝りしましょうと思って。スーパーフルイドのことを聞いた方がいらっしゃいますか？結構いますね。素晴らしいです。スーパーフルイド自体はトークンのスタンダードということで、今日ちょっとそのトークンのスタンダードをちょっと説明したいと思っています。スーパーフルイドのトークンでできることって言ったら、マニーストリーム、それは一番結構人が話していることなんだけど、今日はあとちょっと説明したいと思っています。マニーストリームっていうのは継続的な決済ということが毎秒お金が動けます。で、それで結構資本効率ができます。そのお金の形があまり変わってないじゃないですか。ブロックチェーンでもほとんど似たもんだと思ってます。普通の銀行のお金を使うのは現金と使ったそこまで変わってないです。しかしブロックチェーンでは結構いろいろできますので、そのトークン自体が私たちが変わってて、で新しいお金の動き方を発明してます。でこれでお金を結構変わっていってると思います。 だから、スーパーフルイドでマネーストリーム、毎秒のお金の流れと言います。スーパーフルイド自体は最初に一番大事な部分だというと、スーパートークンということで、トークンの、新しくしたもので、いろいろできるトークンで、毎秒の、決済ができるトークン。で、それにあと一つの部分だと言うんだけど、アグリーメントといって、お金動かす方法。で、これが何個も入れてて、そのスーパートークンにお金の動き方がいっぱいあるということです。で、それの一つはマニーストリーム。だけど、あと3個ぐらいありますから、後からちょっと説明します。で、マニーストリームというのは、ガス無料で、オンチェーン、ブロックチェーンの上でお金を動かす方法と言います。そうですね。普通の ERC20 トークン、それか、銀行の、お金とか現金でも、こういう形でしか動けないんじゃないですか。一定で1対1という動き方しかないですね。で、それで今、ブロックチェーンでできてる DeFi とか、全部この動き方だけで作られましたけど、スーパートークンで、あと、ちょっといろいろ入れてて、で、その継続的な動き方、そして1対 N の動き方も発明してます。前、アグリーメントと言ったんですけど、これはアグリーメント自体でトークンの中に入れてます。で、まだできてないですけど、今年できることで、コンスタントフローディストリビューションアグリーメントって言って、1対 N のマニーストリームになります。で、その上に、プログラマビリティはちょっと翻訳できなかったんですけど、プログラムできる可能性がいっぱいあって、お金をコントラクトに動かすとき、その中にいろいろできます。で、アグリーメントっていうのは、長い時間の金融コントラクトって言って、動き方を説明する言葉だけをオンチェーンに入れて、でそれであんまりトランサクションいらなくて、お金が自動的に動かす方法。だからあんまりブロックチェーンの上にデータを入れなくてもお金が動ける。例えば、簡単に$100月がアリスにあげたいという言葉が結構短いじゃないですか。だから毎月同じトランサクションをするより、やりたいことだけオンチェーンにトランサクションして、でそれから自動的に毎秒お金が動くこと。それか、ある人たちに毎回同じお金をあげたいということもあるんじゃないですか。で、それが1回ユーザーのセットをオンチェーンに入れて、でそれから毎回お金あげるのが安くなる。そういう方法の2つがあります。で、そしたら1つのトランサクションでお金を動かさずに、アグリーメント自体が決済されています。で、アグリーメント自体決済されたら、それからもうトランサクションいらなくて、自動的に毎秒お金が動かせる。で、これはリアルタイム残高が更新され続けることです。で、それはオンチェーンを見たらどうなるかと思ったら、こんな感じです。もうお金が本当に自動的に動いているということで、あんまり人が触らなくてもお金が動いているという形になってて、でいろんなストリームが同じ人の残高に入ってて、で入ってると出てるお金が全部ネットされて、でその残高が動きます。 ということで、まあ、例えば会社としたら入ってるお金とか出てるお金が全部毎秒の決済ができることになっています。で、アグリメント自体は、まあ、その残高の集計ですけど、時間が経つと残高が毎秒自動的に更新されてる。で、そのアグリメントが全部含めて、残高がどんどん動き続けます。で、まあ、みんなの残高が同じ時に同時に決済されているので、まあ、実際そのブロックチェーンの残高を見たら全部毎秒動いてますけど、誰もトランサクションしてない。でそれは結構なんか素晴らしいところだと思ってます。今って言ったら9万ぐらいのストリームがあるんですけど、それが全部毎秒どんどん動いてますけど、誰もトランサクションしてなくて毎秒の決済がされてます。でそれに作りたいのはこういうお金の流れのネットワークみたいな感じで毎秒お金もらったり毎秒お金流したり、っていう形でこういう経済を作りたいですね。でこれは、まあ、流金のネットワーク定義をちょっと入れたんですけど、実は今これポリゴンのネットワークで USDC のそういう流金のネットワークになってて、そういうお金がどんどんいろんな人に動いてて結構面白いですよ。これ本当に未来を見えてるって感じじゃないですか。お金が毎秒自動的に動くのが。でまあどんどん結構いろんな人が入ってて、このマップがもう使えないです。9万のストリームもありますので、もうこのマップがちょっと古くなっちゃったけど、まあ、そしてまあ皆さんもしかしたらイース東京にも来るんじゃないと思っていろいろなんかできることが教えたかったんですけど、まあ、タイプスクリプトとかサブグラフ、そしてまあソリディティのライブラリーとエグザンプルがいっぱいありますので、ドックスに行ってください。でまあ、最終的にまたスーパートークンに戻って2つの種類がありますけど、そのピュアスーパートークンって言ってスーパーフルイド自体で作られたトークン、それが100% がストリームできることになってて、でトークンがもしかしたらもう存在しているトークン、例えば USDC とか、まあ、スーパーフルイドで直接使えませんので、その時だけラッパーが使わないといけないです。でその普通のトークンをラップしてそれからストリームできます。だけど、まあ、もしかしたら皆さんゲームとかを作ろうとしたらピュアスーパートークンにして、でそれからずっとストリームができます。そしてまあちょっとコードを書こうと思って、まあ、普通の ERC20 トランスファーって言ったらこれ普通のお金の動き方じゃないですか。レシーバーといって、まあ、人にあげたい人のアドレスとアマウントでお金を動く。で、ストリームって言ったら似たもんです。あげたい人とフローレート。フローレートって言ったらその毎秒のなんて言えばいい、まあ、お金、動きたいお金で。だけど、ちょっと、あと一つがあるんですけど、まあ、そのフローを読みたいときがその Sender Receiver を入れたらまた毎秒いくらが動いてるのをもらえます。であと一つは Super Apps っていうんですけど、これはちょっと要約はできなかったんですけど、そのコントラクトにストリームしたらコントラクトのロジックを自動的にまあ、使えます。で、それが4つがあるんですけど、まあ、on transfer, on create, on update, on delete。だから毎回そのストリームの状態が変わったら別なロジックが入れますので、それだけで結構簡単な発展なやり方ができます。普通の ストリームだけを開けるとゲームとかのロジックが全部自動的に使います。で、もしかしたらビルドになったら、これは私たちのなんかデベロッパー向けのインターフェースですので、コンソールといってデータとか全部もらえます。で、イース東京に結構$5000のバウンティもありますので、ぜひなんかハッカーがいれば。はい、それでありがとうございました。
Thank you, Fran. Okay, じゃあ質問。
Thank you so much for your speech. Do I have to speak in Japanese too?
どうでもいいです。
どっちも大丈夫？Okay, so do you guys have any questions here? 何かご質問等あれば、日本語でもいけますので。
プレゼンテーションありがとうございました。もしこれをスーパーフライドをゲームとか DApps でそのサブスクリプションのペイメントとして実装するときに、例えば残高不足とかすごく懸念すると思うんですけど、ユーザーがですね、その時はなんかサービスを使わせないとかを実装することってよく多いんですか？
はい、そういう感じになってますね。結構前教えた GetFlow をアプリに入れて、でそれから GetFlow が0だったらなんかアプリが使えないという形で、結構ワンラインでできることですね。お金が入ってたらアプリが使えるけど、お金がやめたら使えないという感じで、はい、ゲームで結構使われていることですね。この前ゲームとインテグレーションしてたんですけど、そのゲームは25000ユーザーが5日で入ってまして、でその人たちがもしかしたらストリームを閉めようとしたらすぐもうゲーム使えなくなるということで、結構スケーラブルだし、インテグレーションはしやすいです。
ありがとうございます。
Alright, thank you so much. Any other questions? Okay.
Maybe you already said this in Japanese. Which chains is Superfluid operating on?
Right. No, I didn't say that actually. That's a good point. Superfluid is deployed on 8 networks at the moment. So we are on mainnet, Polygon, Gnosis Chain, Optimism, Arbitrum, Avalanche, Binance, and Celo. So pretty much everywhere. Not on the newer ZK VMs yet, but we'll see.
Cool.
All right, thank you so much. I have one question from online. Superfluid seems to be effective in many areas. For example, scholarships, freelancing. Which areas of particular interest to you?
Well, at the moment, most of our use is from people paying people. So salaries, bounties, scholarships. We are now starting to explore subscriptions. We think subscriptions are going to be a very big opportunity for businesses in Web3. And for me particularly, I think games are probably the most exciting thing, because with games, you can explore completely new use cases without all the troubles that come with accounting, right? Now, if there's any accountants here, you might know how complicated it is already to track crypto assets. When they move every second, it's even harder. So in order to avoid certain complications, developing in gaming seems to be a very exciting prospect.
All right, thank you so much. So if there is no more question, then we'll move on to next speaker. So thank you so much, Fran, for your speech. That was very interesting. Thank you. All right, so next speaker will be Colson from AdvocatesDAO.
All right, let me know when you're ready. All right, enjoy your speech.
Hi everyone, my name is Colson. I work at AdvocatesDAO, which is a DAO contributing to the Graph network. I would like to thank you guys for being here, and I would like to thank the team for organizing it and inviting us to speak. Also, shout out to all of the other teams here. Good to see familiar faces and meeting a lot of new people. Very excited about next week, about the hackathon, and I hope to see you guys there as well. So I'm going to introduce you to the Graph and Graph Advocates DAO. I'm going to start off very simple with the basic stuff about Web3, and then we will move on to what the Graph does, and we will speak about the hackathon for next week. All right, so let's start here, guys. What is Web3? I would say it is a platform where you can build decentralized applications. And what do we mean by a platform, right? So it's a technology where people can build stuff, and in Web3, that is the case with the Graph. So we're going to go on to the next one here. What are the pillars of Web3? I would say it starts off with a decentralized tech stack. Decentralization in Web3 is super important, and we just already heard from Yuma as well how decentralization is powering Web3. In Web3, incentives drive behavior, and it's all coded. So yeah, it's really nice. We are very proud of the ownership and control that Web3 provides, and I would like to showcase a few more things about that as well. So blockchains are digital ledgers where we can put all of our data, and obviously next week it's all about Ethereum. We can build a lot of applications on it. For example, decentralized finance. We can build a lot of DAOs on it, which are decentralized autonomous organizations, which I am a part of one of them, and I will tell you a little bit about that later on. And we can also have NFTs, which are disrupting art, music, a lot of stuff. So let's move on to the Graph. What is the Graph? The Graph is a protocol that wants to index all of the world's data, and I will tell you a little bit about how that works. So with the blockchain, you have all of the raw ingredients of solving a lot of problems in many industries, disrupting in many industries, but it is not very organized. I would say blockchains without the Graph would look a little bit like this. You would have a lot of data. If you would think of all of these M&Ms as data points, if you have a lot of data, a lot of M&Ms, it would be very, very hard to find a single M&M in the big pile. Now, if you are looking at a blockchain, a lot of the data from all of the applications is put onto one blockchain, and then it would look like this. So raise your hand if you have ever tried to find a single transaction and followed that on Etherscan. So you would go, yeah, I see, okay. You will probably know that that is a very, very hard thing to do, especially if you're going to follow the chain along and along. If there are multiple transactions, or maybe it goes to another protocol, or what. There's a lot of stuff that can go on. So as a developer, you really don't want to have that. You don't want to follow a single transaction from A to Z. It would be very, very hard. So if we want to build decentralized applications or dApps, and you would like to have a very good UI so people like to interact with it, it would probably not be the best thing if you have to follow along with all of the transactions. It would take a long time, and you don't want that because you want to focus on that front end, and you want to focus on the UX. So you need a simple way to organize all of this data, all of the blockchain data, and that is where the Graph comes in. So you could see blockchains with the graph like this. You have neat piles of organized data, which you can then use for your decentralized applications. And as I said, there is a lot of different forms of data, so you could look at it like this. You could have a pile of NFT data, pile of DeFi data, DAO data, wallets and payments, social data, or, for example, network analytics. Now, this is still really, really big, right? If you have all of the DeFi data in one big pile, that's still a lot of data. So what you can then do is you can use the graph to go even more specific. So you could have the DeFi data of one specific protocol. You could have NFTs of one collection, a lot of stuff. So we're going to look into that now. And it all works because of subgraphs. And I just saw it in the other presentation already as well. What is a subgraph? It is a API, decentralized API, that makes organizing the data very easy. So while writing a subgraph, you could say in coding, I need this specific blockchain data, I need it organized in a certain way, and I need it served to me in a certain way. Anyone can publish a subgraph, anyone can query a subgraph, so they're all open source and you can fork them, which we've seen used a lot. If somebody builds a really good subgraph and other people want to use it for their own product, they can just look at the code, change it a little bit, and then move forward with it. So as I just said, as a developer, you don't really want to worry about that, getting the data too much. So that's why we use subgraphs. And the subgraphs are sit between the indexing layer and the query layer of the Web3 stack. So let's assume you want to pull all of that data. You could then use a subgraph to do it. And your resources should be spent on having a great user experience. So whenever you build a good app, people want to use that. So we've seen a lot of projects that are using subgraphs. And if you look at a blockchain like this, you have all of the data that is in one blockchain. And with a subgraph, you can then get it into a certain database. So then you have your own database with your own data. And we can see a lot of the projects here that are already using it. Some of them are speaking here today and tomorrow. And a lot of them are sponsoring the hackathon as well. So it's really, really nice. And you can use them together with the graph to do cool stuff. Now, as I just said, a lot of information, and I have a very AI-powered, super high-tech visualization here. And I'm kidding, but this is live footage of how subgraphs work. You have a lot of the data on the top, and then you can use the graph and subgraphs to filter that data. And then at the bottom, you would see how it looks like in your own little database. All right. So plenty of Web3 use cases are already using the graph. You will probably know some of them. You've probably used some of them. And as the graph is a tool, it's usually on the background. So sometimes it will say powered by the graph. Sometimes it does not. If you want to look at all of the subgraphs by the graph and all of the dApps that the graph powers, you could go to the network.thegraph.com and you would find all of the subgraphs here. These are some examples, but there are hundreds of them. And yeah, a lot of them are in use for a long time. The subgraphs don't change, they just work, and the graph does its thing. So for example, you can see Yuma here. I believe they use it for voting. So that's pretty neat. I have two use cases here. One of them is a use case called Nifty League. And they have a NFT gaming, NFT game, and they use a subgraph to verify the owners of NFTs, look at some of the specifics of the NFTs, and then you can even have a search bar, and that's all powered by a subgraph. We have another one here. It's called Capital DAX, and they use subgraphs to get real-time data for their automated market maker, their ERC20 tokens, trading pairs, trading volume. And if you have all of that data, you can then use the graph to make cool graphs about a lot of stuff, for example, the DeFi data. Another company that uses it, or protocol uses, is Uniswap. If you go to their website, you will see on the bottom, powered by the graph. So how does the graph network work? It's a decentralized network. We have 450 teams of indexers. Those are the ones that are running the nodes and operating nodes and actually querying getting all of the data, indexing all of the blockchain data for a lot of different blockchains, and Ethereum too, so very nice. We have curators that look at these subgraphs and say, oh, which subgraphs are more valuable, which subgraphs need to be indexed, and then the indexers will do their job there. We have 11,000 delegators which secure the network by staking their GRT tokens, and we currently have 800 plus subgraphs on the decentralized network, and I believe, over 40,000 on the hosted servers and Subgraph Studio, which are not decentralized, so those are centralized services that we also host where people can build their subgraphs and test them out. But on the decentralized network, we have 800 subgraphs that are working and that are really good. So the indexers are very technical. Curators and delegators don't have to be technical. And the subgraphs are developed by subgraph developers. And I hope that some of you will develop them next week as well for the hackathon. So the graph is being built by a lot of teams. We decided, or well, I guess it just happened that we are scaling horizontally. So if we have some part of the protocol that needs more work or some part of the protocol that needs more help, we look at the team that does very well. And currently there are 7 teams working on it. So Edge and Node, which is the original team, the Graph Foundation is overseeing the entire operation. And then all of the other ones have specific usages that are on the screen right now. So GraphHubs, The Guild, Mazari, Semiotic Labs, and Streaming Fast are all working on the graph. We also have multiple really big communities of hundreds of thousands of members that are community-driven and doing a lot of stuff that is more non-technical. We also have 3 DAOs in the ecosystem currently, and more of them are coming. One of them is more of community support, which I'm in. One of them does subgraph development. They are called buildersDAO, and one of them is called indexerDAO. It's a team of indexers that are helping out other node operators to get their operations started. So my team is called AdvocatesDAO, and we do community support, and we also do grants for the entire ecosystem, community grants. So for example, if we would like to host an event in Tokyo, then we could apply for a grant with AdvocatesDAO, and people could get a grant for that. So I will quickly go over this. So the mission of AdvocatesDAO, which is my team, is to drive greater participation in building a decentralized Web3 and grow the graph ecosystem by supporting the community. We have a lot of people working for us. We are currently over 300 graph advocates all over the world, including some in Tokyo. So thank you so much for being here. Very good. So we have 300 people, and together we are building the graph. And while we are building the graph together, the graph is also supporting developers by, for example, sponsoring the hackathon next week. So I would quickly like to go over all of the prizes that we have. So the developer focus is on building subgraphs, and you can get 2 prizes. There are 2 categories. One of them is building a new subgraph, so that is building it from scratch. We have a team of developers that are online on our Discord 24/7. So if you have any questions, you can go in there and ask questions about your subgraph development. We will also have senior developers at the booth at the hackathon next week. So if you have questions there, feel free to come by as well. So the first one is building a new subgraph. The second one is using an existing subgraph. So if there is a protocol or a team that already built a subgraph, it's open source, so you can use that subgraph to query it and then get your data for your own application. So that way you can also use that one. And those are the prizes for the hackathon next week. We also have a nice QR code, as was just mentioned. It's a safe one. I just checked it as well. If you are interested in getting more information, maybe join one of the teams, join one of the DAOs, or get more into the network, or get more data, get more information, you can scan this QR code, and I hope to see you all next week. And happy building, guys. Thank you so much.
All right, thank you so much. So is there any question for him? Okay.
Thank you for the presentation. My question is, I understand the graph can be used to look up information on the blockchain. Also, we have something like Alchemy or Infura, which provide API access. You can just call their API endpoint to get the same kind of information. My question is, for dev developers, when should we use Graph and when should we use third-party APIs? And what's the difference between these 2 different systems? Thank you.
Right. So you can use it, for example, on Alchemy or another provider to get your data, but you would still have to index everything. So you could run your own application, run your own infrastructure, but that would be very costly, and you would also have a single point of failure. So what the graph provides is a network of indexers that all get your data. So let's say one of them goes down, you still have redundancy, you still have backups, and it's also a lot cheaper. So you're getting rid of the single point of failure, you're paying less money because you don't have to run your own infrastructure, and therefore you can also focus on developing instead of running the infrastructure. Does that answer your question? Maybe I misunderstood.
Yeah, no, I understand. Okay. It's a more decentralized solutions and APIs, but also it takes you to do more work, but you save the money from, I think.
Right, yeah,
okay.
You save money and you don't have to run the infrastructure, so it's also safer as well.
Got you, thank you.
All right, sounds cool. Thank you for your question and answers. Any other questions? Okay, we got one question from online. So the question is, what efforts are you making to keep the balance the number of workers, for example, curators and delegators, for data integrity?
Right. So the delegators and the curators are non-technical. We don't hire them. It's open for everyone. So we don't really have any say in the numbers. People can just go to the network and start doing that. For data integrity, we have the indexers that are all sending a proof of indexing, and they all check each other. So if one of them provides wrong data, then they will be slashed for about 10% of their total value, which in some indexers, they have hundreds of millions of GRT. So if they get slashed, it's really, really bad for them. So that's how we keep in check, and that's how we keep the data integer.
Okay, great. Thank you so much. So if there is not other question, then we will move on to next speakers. So thank you so much, Colson.
Thank you.
Thank you so much for joining us.
Thank you so much.
So the next speaker will be...
Okay.
Hi, okay. Hey. Thank you.
Okay, so the next speaker is Chris from BTQ.
Welcome, Chris.
All right, so let me know when you're ready.
Yeah, looks good. Okay, just gonna make sure that the internet still works. Thank you. Stacker Rebel. Okay.
Seems working, yeah.
We are live. Good stuff.
All right, go ahead and enjoy your speech.
Thank you. Okay. Konnichiwa. Hello. Pleasure to meet you all. My name is Chris. I'm the head of partnerships at BTQ. With me, I have my colleague, Kaori Tanaka, head of BTQ Japan. And we're very excited to share what we've been working on at BTQ with you all, a project called Keelung. And before we dive into Keelung and before I talk about who we are, can you just get a sense for the crowd here? Is anybody into ZK? Do people like ZK? Zero knowledge? Zero knowledge fans? Nice, okay, yeah, there we go. And is anybody interested in building ZK? Nice, okay, well this is for you. So at BTQ, we were founded by a group of post-quantum cryptographers and researchers with an interest in addressing the threat that quantum computers pose to blockchains and cryptography at large. And in our mission to address these threats, we built Keelung. So Keelung is a ZK domain-specific language for writing and creating zero-knowledge proofs. Our goal with ZK was to help developers write post-quantum zero-knowledge proofs as easy as possible without extensive expertise in cryptography. We're very proud to have 100% open sourced Keylong, and very excited to have launched the alpha release with some of our launch partners, one of whom is Vess, who's in the crowd today, a great Japanese DID protocol, so shout outs to Vess. Another actually Japanese launch partner, DMTP, who's working on a decentralized messaging transfer protocol. But okay, enough shilling our partners. So just in case we're not all on the same page, so just want to get familiar with what zero-knowledge proofs are. So zero-knowledge proof, or ZKP, is this cryptographic technique that allows you to prove something about a piece of information without completely revealing that piece of information. So it's really seen as a privacy-preserving technique. And when we went about building Keylong, we wanted to make sure that we weren't just recreating the wheel, and we wanted to bring something new to the table. So some things that we focused on in building Keylong, which helps you write these zero-knowledge proofs, is mobile witness and ZKP generation, which allows you to construct these proofs, or essentially generate these proofs on mobile phones, which we think is going to be absolutely critical as we onboard the next billion users. Again, our roots in post-quantum cryptography, we see Keylong as an on-ramp to post-quantum proving systems and post-quantum zero-knowledge proofs. So we've kind of designed this in a way so that you can start with pre-quantum zero-knowledge proofs. So for example, like ROS16 or any other zero-knowledge proof based off of which are pairing bases, essentially. And then you can use that same representation, intermediate representation for a post-quantum proving system. So we also support a breadth of both pre and post-quantum proving systems. We've also raised the level of abstraction in this language so that it's easy for people to pick up and learn. And we're also focusing on tightening integration with hardware so that you have the option to essentially scale this proof generation if your application demands. So a little bit about the Keylong language. It's actually embedded in Haskell, which is a popular functional programming language. I'm not sure how popular functional languages are, but if you did computer science in university, you probably got a taste of Haskell. And one of the benefits of this is that we were able to inherit all of Haskell's functions and module systems, and as well as all of its tooling, and so this includes like IDEs. So we have nice syntax highlighting, formatters, all that. So all of that comes straight out of the box. The language itself is actually very small. We essentially built Keylong so that we only address the parts of zero-knowledge proof generation that you need. And we've provided a really nice interface between Keylong and Haskell, so it feels very seamless. You can essentially use all of Haskell's libraries in Keylong. So Keylong also includes a compiler, and so every program that you write will need to be compiled down into a set of constraints, and the compiler is what does that. We spent a lot of time building and optimizing our compiler, or Keylong's compiler, and every program that you write will go through a series of optimizations that ensures the lowest number of constraints possible. And fewer constraints means faster proof generation, also cheaper proof generation, and allows you to scale more easily. So we talked about a pretty small core language, and again, we built Keylong so that we focused on just the elements that are required to build zero-knowledge proofs. So we have 3 primitive data types. The first is field elements, which are essentially just numbers in a finite field. We have booleans, which are actually field elements under the hood, but allows you to express things like true and false. And we also have these unsigned integers of arbitrary bit width, which are also field elements under the hood, but gives you more expressivity in your applications. And these 3 data types allow us to build some really nice, sophisticated proofs. But before we dive into that, we'll just go through a very simple example of what Keylong looks like. So on the right here, we have this square function, which takes x, a public input y a private input, and asserts that y is the square of x. And the reason I show this is because I want to get us into this mode of thinking when we're writing zero-knowledge proofs. So again, ZK is a way to hide some piece of information or to communicate some piece of information without revealing all of that private information. And so when we write a zero-knowledge proof, we'll typically have public and private inputs. The public input is the data that you're willing to share with the rest of the world, and the private is that data that you want to keep sensitive, or that you want to keep to yourself. So let's take a look at an example where we can implement or think about how we implement the rounds of a Poseidon hash function. So the Poseidon hash function is a hash function that was designed specifically for zero-knowledge proofs. It's very, very, very fast, much faster, fast for zero-knowledge proofs. And the way, or the reason it's fast is because it uses this substitution permutation design, which essentially consists of several instances of these rounds. So if we were to implement this in Keylong, we would need to implement each of those, each component of each round. So that would be arc, S, and M for each round. And assume that we have those, then we can simply use Haskell's notation to define a function called round that takes as input an integer, as input a list of field elements, and outputs a list of field elements. And this round function would essentially apply the arc function to the input integer, would apply the result of that to the sbox function, and then the result of that to the mix function. And there you have one round of the Poseidon hash function. So if we were to, or if you wanted to do 3 of these rounds, for example, then kind of we would represent this as a series of functions, right? So you would do the first round on the initial state, and then use the output of that as input to the second round, and then the input of that as, or the output of that as input to the third round. And we can represent this very nicely in Haskell using the fold L function. And it's very elegant, and it's also very safe. So using both Keylong and Haskell, we can leverage Haskell's nice libraries and functionality to just focus on working with the zero-knowledge components on your private and public inputs. So this is an example of how to implement Merkle tree membership proof, or proof of Merkle tree membership in less than 10 lines of code, which would easily take far more in other languages. OK, so instead of just talking about Keylong, let's actually play with it. So yeah, thanks, Gary. OK, just going to use my hands. So we launched a GitHub code space so that it's very easy to get started with Keylong right in your browser. So we'll go through that right now. So here I am in the Keylong examples repo. And to get started with essentially get up and started using Keylong, simply navigate to code spaces, and then you can launch a new code space. But I already have a code space up here up and running. So this code space essentially provides you with a virtual development environment so that you can start playing and writing and interacting with Keylong without needing to install anything. So in this case, we have a nice VS Code environment pre-installed with everything. So we can start interacting with some nice introductory examples here. We have echo. So first, in order to interact with Keylong, we'll open the REPL via stack REPL. And it's compiling everything, which is taking a little bit longer than I thought. OK, there we go. And then now we can actually interact with our first function. So we'll go GF181, which is the finite field that this operates over. You can choose which finite field you use. This just determines the level of security underlying your proof. And then we'll say the function name. And then again, we have public and private inputs. We can look at the echo function and see that it just takes one private function x and returns it. And the way that Keylong is designed is that the first parameter is essentially the public input, and then we'll take 3 as the private input. And it will return 3. This is all done over the internet right now, so there we go. OK. We can also do the same thing with, let's say, the square function, where we'll take two inputs and assert that y is the square of x. So we'll go gf181 square, and let's say 3 and 9. And if this compiles, then it'll have made sure that the private input was the square of the public without revealing what exactly that private input is. We can also see that if y is not the square of the private input, then it just won't compile, and you won't be able to generate a proof for it. And this is all, whether it's you're able to generate a proof or whether it returns true or false is up to you. So how do we elaborate on this to do something kind of more interesting? So let's take the classic example, or I think the most intuitive example of a zero-knowledge proof is proving that I'm old enough to have an alcoholic beverage. I'm old enough to have a beer in, let's say, America. This should actually be prove that I'm greater than or equal to 21 years old, but minor detail. So in order to do something like this, we would need a few pieces of data. We would need my birthday. We would need the minimum age of the state that I'm drinking in, or that I want to drink in, and then we would need today's date. And then using these three pieces of data, you can construct basically N and M, where you show that the number of days that I've lived is longer than the number of days that I need to have lived in order to drink. So I've written a really simple Python script that essentially takes as input the minimum drinking age and then my birthday. And it'll output basically these numbers that I need to run this proof. And so you can think about this as like this can be done by, let's say, like a centralized issuer of someone who people trust can read data and then generate these proofs on behalf of people for. Or if you're a centralized issuer, or if you're a trusted issuer yourself, then you can generate these type of proofs locally. So we'll go back into the REPL and go. We'll use this function down here. Check minimum age. So go gf181, check minimum age. The first parameter is today, which we'll just use as day 0. The minimum age, which is the number of days that I need to be. So minimum is around 7,600. And then nothing as a public input and a private input of how many days I've lived. And if this generates a proof, then the verifier can, and these brackets means that the proof has been generated. Then the VAR can know they can know that I'm over 21 years old without knowing exactly how old I am. All they get is this proof. If we do the same thing, but then change the age to, let's say, 27, right now I'm 26, so I'm not older than 27, we change this input. So we change the minimum days to be older than what I am. This program just won't compile. You see that it has a compilation error. And so what this allows you to do, or allows people to do, is to essentially put these types of proofs into centralized issuers or trusted issuers so that people know that when they receive this proof, they can validate that we're older than some age without disclosing exactly how old we are. Thank you very much. Great, and yeah, that pretty much wraps up this presentation. So apparently there's some security issues with these QR codes, but I think they're safe. They're very much safe. So this is our Discord where you can hang out there and you can hack away on Keylong with us. I'm hacking pretty regularly. I just learned Keylong a couple weeks ago, and so I'm still going through all of these. I'm still in this learning process. And then we also have our GitHub here, which you can check out. So yeah, thank you very much. Arigato mas.
Thank you so much. So, is there anyone who have question for Chris? Yeah, I think me personally, it was very difficult topic.
Cool. Thanks. Appreciate it.
Okay, so if we don't have any question for him, you might like after all, if you have any question, maybe you can just text him. Oh, okay. I thought you're raising your hand. Sorry.
すごい難しい分野なので日本語でも何でも質問があれば大丈夫ですが大丈夫でしょうか。
日本語でも大丈夫ですけれども大丈夫ですか。
あ、nice.
日本語でも大丈夫でしょうか。GK の、回路の言語って、例えば、アズテックのノワールとか、ミナの、スナキ JS とかあると思うんですけど、違いってどういうところになるんでしょう。
So he would like to know what is the difference between other ZK, like Aztec, Mina, or Snack.js.
Yeah. Great question. So we've tried to be as so. We obviously recognize that there are a ton of other DSLs out there, and so we didn't want to recreate the wheel. We built Keylink to be as modular as possible so that you can swap in different proving systems on the back end, both pre-quantum and post-quantum, and making that as easy as possible to do, which you can't do with Snarky.js. Most of these languages only support pre-quantum proving systems. Right now, we already support Aurora, which is a post-quantum proving system. And then also kind of working with our launch partners to integrate kind of new features. So this is tighter integration with hardware acceleration, so that you can very simply when you generate your proofs have an extra parameter that determines whether you want hardware acceleration or to do this at scale. So great question. Thanks.
ちょっとすみません後でちょっと聞いて通訳します。すみません。
Okay, thanks.
I'm sorry. Yeah. I'm gonna hear you later. はい。
So thank you for having us here today. So if you have any further questions, English and Japanese available, we, Chris and I, Kari, are here for you, and so we are happy to talk to you. So and also we are hiring in Japan using the best platform Synapse. So if you are interested in PQC, post-quantum crypto for blockchain or ZKP technology, so feel free to reach out to me or Chris. Thank you.
Thank you.
Okay, thank you so much for joining us today. Thank you for your speech.
ありがとうございました。
はい。明日も香織さんたち明日もいらっしゃいますか？はい。明日もピッチイベントの審査員も香織さんにやってもらいますので、はい、また明日もぜひお話ししてみてください。はい。でしたらですね、ちょっとまた10分ほど休憩を挟みたいと思います。この後5時50分47分ですね。5時47分までちょっと10分ほど休憩挟みたいと思いますので、ちょっとブレイクタイムということでまたお手洗いなどよかったら行ってください。あと残り3セッションですね、残しておりまして、その後はお寿司パーティーを用意しておりますので、お酒とお寿司ちょっとたくさん用意して、懇親会を用意してますので、ぜひ最後まで残りいただいてネットワーキングお楽しみいただければと思います。 はい、そろそろお時間になりますので、ちょっとお席の方にお戻りください。次は政府の、フィンさんからのお話となっております。そろそろお席にお戻りください。じゃあこれ皆さん、次のラスト3セッション始まりますので、どうぞお席にお戻りください。これ大丈夫です。はい。どうぞ皆さんお席にお戻りください。次のセッションが始まります。どうぞお席にお戻りください。皆さん、政府知ってますか？政府知ってる方、どれぐらいしますか？まあもうね、もう定番のウォレット、マルチシグウォレット。はい、来てますね。じゃあ変えましょうか。はい。Okay. Are you ready, Finn?
Hi. Hi, everyone. Thanks for coming. My name's Finn. I'm one of the core contributors at SAFE, previously known as Gnosis SAFE, and I'm just going to give a brief overview of SAFE and our bounties during ETH Tokyo. So I'm going to discuss what is SAFE, SAFE's core protocol, our new SAFE core account abstraction SDK, and also, of course, our ETH Tokyo bounties. So what is SAFE? SAFE is a smart contract account, more commonly known now as a smart account, meaning your account is fully programmable and modular in any way that you can dev without being controlled by a single seed phrase. So this removes the single point of failure that normal EOAs like MetaMask have. SAFE is available on 12+ networks, much more if you include testnets. We have about 4 million transactions, $39 billion worth of assets stored, and 1.5 million safes have been deployed so far. SAFE's total TVL of 39 billion is actually greater than all of ETH's L1 DeFi combined, which I think is pretty cool. And some fun facts, 10% of all USDC are held on safes. More than 2 million ETH are on safes. Just under 1% of all L1 gas is consumed by safe transactions, and SAFE protects almost every major NFT collection. So most people know SAFE for Safe Wallet, which is the multisig and the transaction flow. So SAFE's transaction flow is different from an EOA, where EOAs require a private key to deploy any transaction on chain, whereas SAFE's transaction flow requires multiple signers and a threshold to be met, which completely reduces that single point of failure that we see normally is the cause of hacks. But SAFE really unlocks a lot more than multisig, and multisig is just the tip of the iceberg, and I'm going to go into some of the features that SAFE can unlock. So we have what we call SAFE modules, which increase the access control logic of your SAFE. So this can be through roles like admin rights, token voting, and spending limits, as well as recovery modules like social recovery, secret questions, and custodial recovery. We also have modifiers like time lock, cooldown periods, grace periods, and bonds. The example I normally give for SAFE modules is if I have a treasury of, let's say, 1,000 ETH and I want to hire a trader, I obviously don't want my trader to have access to my whole entire treasury, but I also don't want to co-sign every single transaction he makes. So you could make a combination of all of these to have a module that allows one specific address the right to trade 10 ETH in a week period with contracts that you have predetermined. On the other end of that, we have transaction guards, which decrease the access control logic of your SAFE. So that would be through allow and deny lists, freeze account, and MEV protection. The best example of this is if you're a DAO and you know you only ever send funds to 20 addresses, you could put them on an allow list. And if you try and make a transaction that's not on the allow list, you'd have to have a greater consensus than the threshold to be met. But SAFE really is much more than that. And we recently launched our SAFE Core Account Abstraction SDK, which now has an auth kit, on-ramp kit, and relay kit, as well as the protocol kit that I just mentioned. We're trying to bring Web 2-like UX using Web 3 technologies to the user to empower the user to be able to remove friction while being able to use the security of a smart contract account. With our great partners Web3 Auth, Gelato Network, and Stripe, you can now social login directly into your safe using Gmail instead of having to create an EOA to log in and be a signer, as well as dApp-sponsored transactions by Gelato Network, which is unlocking gas abstraction. So now you don't need to have the native token to pay gas, but the Gelato Relay network will pay the gas for you, and you just have to pay it in USDC. And as well as that, you can now directly on-ramp into a safe, so you don't have to put your funds into a third party and then send it into a safe. You can just remove a single point and directly on-ramp. But Safe is now working on a recovery kit, a multi-chain kit, to make your usability much more easy. And so soon enough, you'll have the recovery kit. But now, during ETH Tokyo, we'll have our bounties, and that will be $10,000 to anyone who builds the best thing using any of our stacks. So it doesn't have to be specifically anything, but any of them. And yeah. Thank you very much. I know it was a bit short, but that's a general overview of Safe. And if you'd like to know more, feel free to go to core.safe.global or scan the QR code. Thank you very much.
All right, thank you so much. So, is there any questions for Finn? Actually, he speaks Japanese very well, so.
まあまあ、あんまり上手じゃないけど。
上手じゃん。
全然。
Yeah, unfortunately I don't, so I'll keep this in English.
Cool.
That's fine.
So just with account abstraction on Ethereum, I mean, what does that imply for Safe? Is this like, essentially it seems like you guys provide this right now, which is awesome, but does that do anything to, how are you guys thinking about this?
So I mean, Safe has been account abstraction native since 2017 when we launched. We were the first smart contract account. I think now it's just much more about empowering users and reducing friction. That's why we launched the Safe Core SDK, so you don't have to go through an EOA and you can just directly use a Safe. Yeah, I mean.
Is there any benefit to using Safe versus like a native EOA?
So the main benefit is you're removing the single point of failure. So if you lose your seed phrase with a MetaMask, your funds are gone for good. Whereas if you have a Safe, if you have 3 out of 3 signers and you require 2, if you lose one of them, your funds are not lost, basically. That's the main use case, yeah.
And then when there's account abstraction on Ethereum, is there any benefit to using Safe versus that? Or?
Yeah, so I mean, the point of using Safe would be that to remove the single point of failure, and it being on Ethereum is just much more about making smart contract accounts first-class citizens, because obviously right now you can only use dApps that are integrated with our app store. But once account abstraction is native everywhere, you should just be able to use a Safe directly without ever having to, for us to have to do the back-end work to integrate with dApps.
Okay, thank you very much.
Cool.
All right, thank you for your question and your answers. Is there any other questions for Finn? Okay, so he's saying that he is going to use Safe in ETHGlobal with his project, Akindo.
That's a good idea. You definitely should. And you should also have a look at Zodiac modules, which are pre-built modules on top of Safe, so that you don't have to custom make them. Yeah, yeah, exactly.
Okay, thank you so much. Okay, so thank you for your speech, Finn. Thank you.
It's very short.
That's fine. Time is money, right?
Yeah, I guess so.
Okay, so next speaker will be Shannon from Livepeer. Shannon, online です。I didn't mean for it to be so short. Hi, Shannon. I'm Taka.
Hi.
Nice to meet you.
Taka, it's nice to meet you.
Okay, so next speaker will be Shannon from Livepeer. Is there anyone who knows Livepeer here? Oh, that's great. I see some people raising their hands. That's pretty cool. Okay, so let me know when you're ready. Are you ready?
Yeah.
Okay, nice. So enjoy your speech.
I'm just getting my screen share set up
Okay,
here.
sure. By the way, good morning. What time is it there now?
Hi. Yeah, it's 5 a.m.
5 a.m.
A great
We are
time.
so sorry about the time gaps.
No, it's okay. I wish I could see who was in the audience. I can only see
Okay,
myself
I'll send you a
right
picture later then.
Cool. Yeah, how many people are there?
Right now, okay, let's say 50, 60? Okay,
Oh,
let me
wow.
just say 100 people. Okay.
Cool. Well, I'm excited to see you in a couple of days when I land in Tokyo. I'm in Toronto, Canada right now. So I'll get started. I think we're going to have about 5 or so minutes for Q&A at the end. Is that
yeah.
right? Awesome. Okay, cool. Well, my name is Shannon, and I'm head of ecosystem growth at Livepeer. And Livepeer is building the future of video in Web3. And I'm excited to talk to you guys today about what is Livepeer, what you can build with Livepeer, and what we've got going on at ETH Tokyo. So
Okay,
I'd like
Shannon,
to start
sorry.
off.
I think your
yeah.
slides is very small. Oh, yeah, now it works. Okay, thank you. Now it works.
Okay, it's working?
Yeah. Thank you.
Okay, what about now?
Now it's small. I don't know why.
Okay.
Yeah.
Just a sec. Okay, we're going to give this a second try.
Yeah, take your time.
Okay. I think you
thank you.
guys should be seeing that now.
Yeah, I can see it.
Yeah? And
Yeah.
what about now? Is it small?
No. I don't know why. Now it's very small. Now it's good.
This works?
Yeah.
Okay. I don't have my speaker notes, but that's okay. We're gonna
I
go
see.
through it.
Okay.
We're good?
Yeah, let's go.
Okay, cool. So Web3 is about utility. It's not about speculation. And oftentimes when we think of Web3, we think of DeFi or prices going up and down. But there's a lot more going on with Web3 that is really about providing real value. And so the idea is that the internet is actually providing utility and services. And I kind of like to think about the idea of internet public works and actually reshaping the infrastructure that's underlying the internet. And Livepeer is one of the projects that's part of the Web3 Index, which is a really great consortium of other Web3 infrastructure projects who are all kind of decentralizing different parts of the internet technology stack. So other members of the Web3 Index include the Graph, which is like the Web3 version of Google that's doing decentralized search and query. We have Arweave, which is doing decentralized storage, and Akash, which is a decentralized cloud service. And the vision for Livepeer and other partners in the Web3 Index and the Web3 technology stack is that ultimately decentralized applications and developers building decentralized applications will all be using different parts of the Web3 technology stack together. And so I want to talk obviously specifically about Livepeer and what part of the internet technology stack we are decentralizing, and it's video. And video is actually the largest part of the internet today. It's about 80% of all bandwidth on the internet. And it's easy to understand why, because not only is video a huge aspect of the internet, it's also a huge aspect of being human. It's the closest analog we have to being together in real life. And we want to consume video online in growing amounts. And this chart's really interesting because it shows that the average person spends about 5 hours a day online on video. And if you look at the red bars, they're actually going down, and that represents traditional television. And correspondingly, the black bars are going up, which represents digital video. So over time, we're also seeing that the amount of time we spend watching a traditional TV, we're starting to watch online. And so Livepeer is really trying to tackle that challenge of actually putting video on the internet. And because the demand for video is expected to increase about tenfold over the next 5 years, we really need a more scalable and cost-effective solution to keep up with the bandwidth demands for video streaming online. And what makes video streaming so difficult? Well, videos are recorded in many different files. So if you record a video on your iPhone and you want to put that on the internet, that file is not likely going to be compatible with a browser, with different browsers at different bandwidths in different parts of the world. So those raw video files need to be reprocessed into different formats and sizes so that they can be received on different devices. And so how many of you have ever tried to watch a video online and experienced buffering? Probably a few of you. So why buffering happens is because video hasn't been transcoded. And transcoding is what ensures that no matter the bandwidth, location, or device, viewers get the best playback experience and you don't get that buffering. And so how video streaming works today is that there are actually only a handful of centralized cloud providers who have the ability to provide that computational infrastructure at scale to meet the world's video demands. So if you're a broadcaster, you would send your video to a media server, and then it goes to a CDN, and then it gets processed out. But again, because there are only a few internet service providers today who can provide that, they're able to overcharge for that service. So what Livepeer is doing is really trying to decentralize through its network those key components of putting video online. So Livepeer is a transcoding network, and it's both a content delivery network that leverages peer-to-peer compute. And how does it do this? The Livepeer protocol, which is a proof-of-stake protocol built on the Ethereum blockchain, we now run on Arbitrum Layer 2, actually provides for different participants in the network who provide computational capacity, CPU, GPU, and bandwidth necessary to do transcoding. And the orchestrators that run nodes on the Livepeer network earn inflationary Livepeer token rewards for doing that, and they also earn fees in Ethereum for doing the work of transcoding. And when a broadcaster pays an orchestrator, the orchestrator receives that reward, and it can also share that reward with delegators who've staked their Livepeer token to node operators. So if any of you are familiar with proof-of-stake protocols or even DeFi protocols, they kind of work in the same way. If you don't have so much token that you want to stake it to run a node, you can delegate it to someone who is running a node, and you can earn an APY or share of those rewards. And so with those token economics, Livepeer has created the world's open video infrastructure. And the network launched in 2017, so it's been a while. And the first 4 or 5 years were really focused on getting the supply side of the network up and running, getting that global network of node operators providing the bandwidth and GPU and CPU capacity to do transcoding. And so the result is we now have an always-on incentivized network that is reliable and more reliable than centralized servers because you have the redundancy of different nodes all around the world. And the intelligent distribution designed into the software guarantees that transcoding never stops. So if a node is unavailable, another takes over. And that's part of the beauty of decentralized computational networks. And so Livepeer also scaled infinitely because it's an open and permissionless protocol, so anyone can come in and join. It's permissionless. And it really taps into the global pool of untapped computing resources. And the amount of computational capacity Livepeer has on its network today rivals the cloud compute available with Amazon. So Livepeer hosts an API gateway and SDK that provides video on demand, live streaming, delivery recording, transcoding, and multi-streaming services. And we're now transcoding about 2 million minutes each week, which is a lot of video. And so because we're able to leverage decentralized compute through peer-to-peer networks, Livepeer's transcoding services are about 10 times cheaper than traditional centralized services. And that makes a huge difference if you're trying to do video at scale. So Mux and AWS are two commonly known competitors to Livepeer and Web2 who are centralized providers. And you can see the difference in the cost per hour of doing transcoding on Livepeer's decentralized network versus a centralized network. And just to kind of do the calculation, if you're trying to run a Twitch-like application with 1,000 concurrent streams for over a month, it would cost you about 300,000 US on a Web2 stack versus only about 45,000 on the open Web3 stack. So that's a pretty big difference if you're trying to create a video streaming business application. And so why is it really important? Why is that economics really important? Because as I mentioned, because there are only a few internet monoliths today, the big Web2 monopolies who are able to provide that video infrastructure at scale, they also create a really closed developer environment so that the applications are controlled also by the infrastructure. And just as an example, YouTube actually had to sell to Google in 2008 because it couldn't cover its infrastructure costs as a startup. It had to sell to Google. And similarly, Twitch had to sell to Amazon because it was running at a loss. And Twitch continues to run at a loss for Amazon because its infrastructure bills are so high. And as a result of this, these internet companies, Facebook, Google, Amazon, they take a huge creator take rate on the creators on their platform. It also causes problems for developers who can get locked into different platforms. So I don't know if any of you in the audience are familiar with Patreon. It's a large creator platform here in North America that serves independent creators. And Patreon had an agreement with Vimeo, which is one of the world's largest video services providers. And Vimeo changed its business model when it decided that it no longer wanted to provide service to independent video streamers at the cost that it was. And they increased the annual bill for independent creators from $500 a year to up to $5,000 a year. And Patreon couldn't get out of that deal, and its creators were really left out. Some other adverse effects as a result of having Web2 social and video platforms is that they own the content that their creators put on the platform. And so if ever you get deplatformed, those platforms take your content with them. And we've had cases of that, in the last year or so, where Bankless actually got banned from YouTube and it lost its follower base and its content. It did get reinstated. But this is, some of the problems that can happen with centralized Web2 media companies. And so kind of the end economic result, the value of the creator economy last year was estimated to be over $100 billion USD, and YouTube's creator ecosystem alone was valued at $25 billion. But the issue is that the pie is not split evenly. So YouTube takes about 80 cents on every dollar that a creator makes on its platform, and the Twitch rate is about that. And so it takes a really long time for a creator to earn a sustainable income on these platforms today. So less than 2/3 of creators who are online, or two-thirds earn less than $25,000 a year. So that's the vast majority of creators really don't make that much. And more than a quarter earn less than $1,000. So with the unit economics that's possible with distributed compute and decentralized networks, combined with the other primitives of Web3 technology that allow users to own their content, to own their identity, to own their data, and to make sure they comport that and take that with them across platforms, at Livepeer, we're really excited that those things together are really what can enable the future of Web3 creator and social applications. And so now I want to talk about how you can easily get started building a video application using Livepeer today. So we have Livepeer Studio, which is the developer gateway to the Livepeer network. And it's an API that lets you put live streaming, video on demand, and other Web3 video features into a front-end application. We also have an SDK, a JS SDK, which allows you in just a couple of lines of code to actually embed a Web3 player directly into your front-end application. And we're always working on new Web3 video features. So beyond just the bread and butter video live streaming and video on demand, Livepeer is really exploring what's unique about video in Web3. What video products are possible in Web3 that are fundamentally not possible in Web2. And one of the really exciting ones that we released a few months ago is actually decentralized video streaming playback from decentralized storage. So you can upload a video to a decentralized storage provider, whether that's IPFS or Arweave, and you get a CID or a transaction hash, and Livepeer will cache that video, and then you can get the CID or the hash and put that directly into the Livepeer SDK front-end player. And why is that so powerful? Why is it so powerful to be able to stream a video from IPFS or Arweave? Well, it provides guaranteed playback quality because on their own, IPFS or Arweave do not do video transcoding. They're also not content delivery networks. And together with Livepeer and storage providers, these are chain agnostic technologies. You can put Livepeer and decentralized storage in any smart contract environment. And what's also really super cool, and we're just starting to explore the implications of this, is when you have kind of the CID at the base layer of a video compute pipeline, you get verifiability of that content through basically the life cycle of that piece of content. So one of the really future looking things we're starting to explore at Livepeer is what other forms of video compute are possible on top of that metadata. And that includes, AI, which is another form of, GPU intensive computation that's possible on Livepeer's decentralized network. And so, yeah, the CID remains the root of the pipeline. And you can imagine doing all kinds of other enhancements or remixes to that kind of data and getting a verified enhanced output at the end of the process. And so this is I don't know if you guys can see this, but it's a pipeline of potential different ways that a video input could be changed through different types of computation, whether that's audio transcription or text to image, to create a new video output. The other really exciting feature that we actually just launched last week is token gating. And that's token gating for both live streaming and video on demand. And we're really excited about what token gating is going to unlock for communities to help them both monetize their content and also to engage their community members. So if you have NFT-based membership for your community, you can decide that only those members are going to get to see the video content that you have. And so we're really excited to see what everyone in Tokyo is going to build with Livepeer over the next week. And there are a lot of applications that you can take inspiration from in the Livepeer ecosystem. We've got some Web2 companies, the Lot Radio, which is right in the middle, is actually a DJ streaming platform that's based in Brooklyn, New York, and they've been using Livepeer for a few years now for live DJ streaming. We have metaverse projects like Decentraland and Mona, who now use Livepeer to enable metaverse creators to create live stream scenes using Livepeer directly in the metaverse. We have Orb, LensTube, and a lot of other apps that are built in the Lens ecosystem, because Web3 social and decentralized social graphs are a really important primitive when thinking about video applications. And that's where most of Livepeer's growth has been, I would say in the last like 6 to 10 months, has been with Lens, because Lens is also providing monetization features for content. And so much of social media is video that it's just a really natural space for social application development to happen is around video. Huddle 01 is also an application that's powered by Livepeer and IPFS. It's kind of like a Zoom for Web3 that also has token gating and NFTs. The 402 is a live streaming platform and NFT marketplace. And this is a really good example of kind of what's possible for creators in terms of, again, the economics of Web3. So the 402 did a token gated live stream with a musician who in about 2 hours raised over $1,000, which as a Twitch streamer, it would take him over a month to make that much money. So you can start to see the potential for creators to really see economic benefits through Web3 applications. And so we have a bunch of programs at Livepeer that are, tailored to whatever stage of development you're at. We have programs for people who want to experiment, and those are hackathons and other online challenges that we do, and bounty programs. We have a really great grants program that has both micro builder grants if you're just trying to complete some features in an application, as well as a larger video disruptors grant if you're doing something that's truly groundbreaking, that's demonstrating a video use case in Web3 that's really not possible outside the context of Web3. We have grants for that. We also have an accelerator program if you're looking to raise venture capital funding. And we also have infrastructure credits if you're already at scale and you have high volume needs. And that QR code is going to direct you to our ecosystem resources, which actually has a full list of the applications in the Livepeer ecosystem, as well as a really good resource guide. It's actually on GitHub, and it's a community contributed ecosystem resource, so you can check that out. And yeah, we are at ETH Tokyo. We're really excited to be one of the sponsors at ETHGlobal Tokyo next week. And we have some really exciting prizes. Our top prize is for the best token gated video application. And as I mentioned, that is a really hot new feature. It just came out last week. So really excited to see what people will build with that. We also have a prize for best video-based NFT app. And would love to see more than just an NFT marketplace per se. I've been talking to a lot of podcasters in Web3 lately, and one thing that they've said they would really like is a way to bootstrap the cost of creating like an entire season of content. And one idea is creating a platform that lets podcasters tease short form versions of longer seasons that they would like to create as a way to, both fundraise and engage members. So you could like imagine creating or minting an NFT out of a really short form video clip that's meant to tease a concept you have for an entire season podcast. That would be a really cool app we'd love to see. We also have a prize for best integration of Livepeer with any other Web3 technology, because we always love to see how Livepeer can be used in the Web3 stack. We're also going to have an ETHGlobal workshop that's going to be given by Livepeer CTO and co-founder Eric Tang, and Eric's really going to dig into what the Web3 creator opportunity is, and some more ideas on how you can build with Livepeer to tap into that. And that workshop is going to be, it is recorded and it should be live on the ETHGlobal website pretty soon. We also have a really exciting event happening with the Livepeer Japan community on Wednesday, April 12th at Crypto Base from 4 o'clock to 7 p.m. I'm super excited about this. We have an amazing lineup of speakers that's going to be announced in the next couple of days, including the founder of Flow Blockchain and CryptoKitties, as well as one of the founders of IPFS and Protocol Labs, as well as some founders from the Japan Web3 startup ecosystem that I'm super excited to have there. And so it is technically sold out, but if you scan this QR code right now and sign up, and one of the questions is, how did you hear about this event? And if you just put in ETHGlobal Builder Session, I will open up some spaces for you for that event. And then finally, join the Livepeer Japan Discord. I am so grateful to the Livepeer Japan community, especially Taika, who's done so much work as our ambassador for us in Japan. We have, a standalone Discord server for Livepeer Japan. It's actually the first region in the world that's had its own Discord server outside Livepeer. So we're really excited about that and hope to see it grow over the next week. And that's it. Thank you so much. That's my handle. It's my handle for Telegram and Twitter. So you can find me there. My DMs are open. And that's it. Would love to take any questions.
All right, thank you so much. I think you had the earliest speech you ever had, right? It's 5 a.m.
The earliest?
Yeah.
Yeah, it was really early.
Yeah, thank you so much. So, okay, is there any questions for her? I actually got some questions, but there we go. Okay, so one question is, what is the big differences between Theta and Livepeer?
Oh, really good question. So Theta, so a couple of, the biggest difference is Theta is actually a private blockchain. So Livepeer is open source, which means you can see all of the code, you can contribute to it. It also Livepeer also runs on a public blockchain. Ethereum is a public blockchain. It's an open source blockchain. Theta is private. It's its own proprietary blockchain, its own proprietary software, so you can't really contribute to it. So that's at that kind of meta level. From a video technology perspective, Theta doesn't do transcoding. It basically like pumps content through its content delivery network, but it doesn't do transcoding. So I can't validate this for sure, but I would imagine that the cost structure is still going to be a bit different if you're using Theta.
I see.
Because it's not leveraging that. It's not leveraging the transcoding network.
Okay, thank you so much. And we actually have some more questions, but we are running out of time right now. So yeah, that's very sad though. Okay, so I'll see you on 20th, right? Okay, thank you so much for joining us today, and I'll see you there soon.
You.
Okay, thank you so much.
Bye.
Bye bye. Thank you.
Bye.
Have a good rest.
Thank you. Bye bye.
Bye bye. So the next speaker will be. まだですか？
ちょっと次の。
大丈夫ですか？So the next speaker will be Antonio from zksync. This is the last speakers we have today.
はい、今日スワッグも提供していただいていた zksync さんのセッションがラストとなりますので、ぜひ何か質問がある方は質問してみていただければなと思います。そろそろズームに入ってきますね。少々お待ちください。 じゃあ、タカさん、アントニオさんに振ってもらっていいですか。
もういます。
もういます。はい。
Antonio, are you there? Let me know when you're ready.
Yeah, I'm ready.
Okay,
so
cool.
If you want
Okay.
me, I can start.
All right, so enjoy your speech. There you go.
Okay, thank you. So let me share my screen first. There we are. I guess everyone is seeing that. So
okay.
hello everyone, and thank you so much for having me. I hope you're having a great day and that you are enjoying the conference so far. I'm very excited to talk to you about what I think is the recipe for mass adoption of public blockchains. Okay. So my name is Antonio. I'm a developer relations engineer at Mata Labs, and I have around 15 years of experience as a software engineer in a lot of different roles. As a dev role, my job is to help projects build on zksync and also to educate developers about all the awesome features that zksync era offers and the different tools that we provide. Apart from that, that's my Twitter profile in case you want to follow me there. And Solidity Tips is a blog that I started back then when I was learning Solidity. So if you are starting to get into blockchain, that's a good place to go. So at Mother Labs, our mission is to accelerate the mass adoption of public blockchains because we think that will break financial barriers and enhance the world's freedom. Of course, Ethereum is the largest public blockchain by many different metrics. So our job during the last years have been focused on scaling Ethereum in particular. Okay, but how do we achieve mass adoption? Well, I think that to achieve mass adoption, we need 4 different ingredients. First one, we need to increase throughput. Ethereum right now is able to process, we need Ethereum to be able to process thousands of transactions per second in order to serve the next billion of users. Second, we need lower transaction fees. If we want to build a huge ecosystem of projects, they should be cheaper to use. Third, we need better user experience because currently Web3 user experience is very difficult and has no safety nets, and you can lose all your money by just doing a misclick or sending a wrong transaction. And finally, tech should be transparent because average users don't care about the technology used to build a product or an app. They want something that just works and that doesn't stay in their way. So these are the areas that we are focusing on, and I'm going to tell you how we have approached them so far. So first, we built zksync Lite. zksync Lite or zksync version 1 is a rollup for payments and token swaps. It was like a proof of concept for zero knowledge technology on mainnet, and it was released on June 2020. Still today has the lowest fees on average. And you can see that's an image from l2fees.info. And it's processing more than $12 million per month in transactions. And the current TVL or total value locked is around 85 million. It's used by projects like Gitcoin. If you have submitted a bounty, you probably got your reward through zksync Lite. But that was 3 years ago. It's been a while, and since then, we have also built zksync Era. Era is a general purpose layer 2 rollup that scales Ethereum with cutting-edge zero-knowledge tech, and it's powered by a zk EVM. So let's get into more details. First of all, it's general purpose. So Lite was limited to payments, but Era is fully programmable. You can write any smart contract and build any type of application. like decentralized exchanges, tokens, NFTs, marketplaces, games, wallets, anything you can think of. It's a layer 2, which means it works with another blockchain, which is the layer 1, and in this case, that's Ethereum. And the main purpose of a layer 2 is to improve the scalability by moving the execution of the transactions of chain of the layer 1 onto the layer 2. And these transactions are executed by our zkEVM with almost instant execution, because it creates blocks like every second. It's a rollup, so it bundles transactions together into batches before sending the transaction data to the L1. And by putting the transaction data in the L1, we inherit the security from Ethereum. And finally, it uses zero-knowledge tech to generate proofs that the transactions executed on the L2 are valid and submits that proof to the L1, where the proof is verified. Basically, it relies on math and cryptography, while other rollups, like optimistic rollups, they rely on proof systems. So yeah, trust math. Some characteristics of the zksync era's EVM is that it's programmable with Solidity and Viper. Other ZK rollups use specific programming languages, but on zksync, you can write with Solidity and Viper and compile your contracts with our compilers that are called zkSorg and zkViper, and they generate the bytecode that our zkEVM will execute. It's compatible with the Web3 API, which means that you can use methods, the same methods that you're used to, like get block, get transaction receipt, everything is the same. And we also have additional methods for zkSync specific features like L1, L2 communications. The security is inherited from L1, as I mentioned before, because we are putting the data of the transactions available on the L1. And finally, we can say that it's an EVM plus, because it also has features like native account extraction, which I will talk about a little bit more later, paymasters, and L1, L2 communication. So why do we need layer 2s? I'm sure you've seen this diagram before. It's the blockchain trilemma. And basically it says that a system can only achieve 2 of these 3 goals: scalability, decentralization, and security. In the case of Ethereum, it's one of the most decentralized and secure systems, but scalability is its weakest point. It's currently able to handle around 12 to 15 transactions per second, but in times of big loads, when there are a lot of people using the network, transaction fees are very, very high. So zkSync era solved this problem in 2 different ways. First, by moving the execution of the transactions to the layer 2 and generating the blocks much faster, we increase the throughput, so that's more transactions per second. And secondly, we're using call data to send the proof that the transactions are valid and the updates in the state of the network. And we are sharing all the fees between all the transactions in a single batch. That way, we reduce the gas fees. So with a layer 2, we are actually checking all the 3 boxes of the trilemma. Okay, so how does it actually work? Well, it works with smart contracts. A layer 2 has smart contracts deployed both in the layer 1 and in the layer 2, and these contracts interact with each other to keep the consistency of the state. In the case of ZK rollup, we send a proof from the L2 to the layer 1, and the proof is verified by the smart contract in layer 1. You can see in this diagram that the layer 2 generates blocks much faster. And once it has enough transactions, it puts them together into a batch and then creates the proof, sends the proof to the L1, and that's where it's verified. So from a user point of view, how do you actually use zkSync? First, you need to deposit your funds into the contract in the L1. Then your funds will be available on zkSync era. At that point, you can interact with any application. You can go to a decentralized exchange. You can buy NFTs, play games, whatever you want. And all these transactions are executed by the ZK EVM. When there are a lot of transactions, the system puts them together into a batch, and then a proof that all those transactions are valid is generated and is sent to the layer 1. And finally, the proof is verified in the L1, and the state is updated. So it looks pretty simple, but this process of putting all these transactions together, generating a batch, it's happening constantly. So if you are a developer, how do you build applications on zksync era? First, you create your smart contracts with Solidity and Viper. If you already have an application, you are most likely good to go, and you won't need to do any changes in your smart contracts. Next, you need to compile your contracts using our compilers. Again, these are zkSolk or zk Viper, depending on the language that you're using. And we're using a different compiler because the bytecode that they generate is the bytecode that is compatible with our ZK EVM. Then we have our SDKs for front-end integrations or for backend. Our SDKs are built on top of the most popular libraries. So for example, the JavaScript SDK is built on top of Ethers, and it uses the same classes and methods like provider, wallet, contract. It works the same way. So in most cases, you just need to change an import or even keep using Ethers, for example. I will show you some examples. To deploy your contracts, you will use our zksync deploy package. And once it's deployed, that's it. Your contract is in the network, and you can interact with it as you always do. You can use MetaMask or Trust Wallet, or you can use any other wallet. So yeah, I'm going to give you a few examples of code and the differences between Ethereum and zksync. And here is a code sample on how to interact with a network. We're retrieving the network details, the current block number, and finally retrieving a transaction receipt. This is on Ethereum. And in zksync era, you will do it like this. And obviously, you have a different RPC endpoint because we are pointing to a different network. But apart from that, we're doing exactly the same. We're even using just Ethers because, as I mentioned earlier, zksync era is compatible with the Web3 API. So it's exactly the same methods: get network, get block number, get transaction receipt. Everything works exactly the same. Here's another example, and in this case, on the right, we are using zksync Web3, which is our own library built on top of Ethers. And this is how to interact with a smart contract. Again, as you can see, we are using the same classes. So provider requires an RPC endpoint to instantiate it. For a wallet, you need the private key and a provider. And for the contract, you need the contract, the API, and a signer. And to interact with a contract, you just use the method, pass the parameters. Everything is exactly the same. So from a code point of view, everything is pretty similar. So if you have an existing project, what do you need to do? Well, as I said, most Solidity and Viper smart contracts will work out of the box, and you have to do minimal changes in deployment scripts and front-end integrations. So if we go back to the mass adoption ingredients, we have checked the first two boxes. With zksync era, we increase scalability of Ethereum by moving the execution of the transactions to the L2, and we reduce gas fees by bundling transactions together into batches and splitting the fees between all the transactions of the batch. But what about the other two, better UX and transparent tech? Let's see how to take care of those. So with these problems is the main goal of account abstractions, and let's see how to do that. Well, instead of using accounts linked to a signer, which logic is hard-coded in the EVM, we'll use smart contract accounts. And to replace the signer, these contracts will implement its own logic to verify transactions on the smart contract. In summary, with account abstraction, what we want to do is use the smart contract accounts. So what features can we unlock with account abstraction? We can do social recovery. If you lose your key to your wallet, you can recover it through email, for example. We can have accounts with spending limits or application-specific accounts, like an account that can only be used to interact with Uniswap, for example. All that logic can be put in the smart contract account. We can have different signature schemes. We can allow users to pay fees with ERC20 tokens or even do gasless transactions thanks to paymasters. And again, smart contract accounts, they are smart contracts. They are fully programmable. So any logic you can think of, you can put on them. And how is all that possible? Well, with EIP 4337, which implements a new transaction flow for smart contracts accounts. And this is the way it looks. On the top, we have the transaction flow for externally owned accounts. That's your MetaMask or your Trust wallet. And yeah, these wallets, they generate transactions, put them into the mempool, and they are picked up by nodes and validators, and then added to blocks. For smart contract accounts, with EIP 437, what we have is a completely new transaction flow, and smart contract accounts send transactions that are now called user operations to a completely new mempool. This mempool is monitored by bundlers, which take the user operations and bundle together into batches and sends them to the entry point smart contract. And the entry point smart contract verifies the transactions and execute them. And once they're executed, they're added to a new block. And when is this available? Well, EIP 457, it's live. The entry point contract was audited and deployed on mainnet on March 1st. And there are multiple providers offering services to run bundlers and paymasters. And that's on Ethereum. And this implementation is great because we have programmable smart contract accounts, which can offer an improved onboarding for users, social recovery, and some of the features that I mentioned earlier. But it also has some not so good features. First, these changes are not implemented at a protocol level because that would have required a hard fork, and we know how long those take. And as we saw, we have two separated transaction flows, one for externally owned accounts and another one for smart contract accounts. And that means that paymasters are not available for EOAs, which is very bad because like 90% of users use externally owned accounts like MetaMask, so they will not be able to take advantage of paymasters. And finally, all these improvements have no, the transaction fees are still very high on Ethereum. There's nothing they can do about that. So can devs do something? Can we take EIP 4337 one step further? Well, yes, we can. Because at Matter Labs, we have built a protocol completely from scratch, and account abstraction has been in our radar from day one. So we have implemented it in a little different way. First, it's integrated at a protocol level. So we have built a simplified solution, both for users and developers. Account abstraction and paymaster are first-class citizens. So under the hood, all accounts, even externally owned accounts, behave like smart contract accounts, and all accounts support paymasters, which is huge. We have a single mempool and transaction flow. All transactions follow the same transaction flow, no matter if they are initiated by an EOA or a smart contract account. And we have our own version of the bundler and the entry point inspired by EIP 4337. The bundlers, they work exactly the same. They pick transactions from this single mempool. They pass it to the entry point contract, which in our case is called the bootloader, and they are processed by the system. And this is how it looks. as you can see, it's a simpler transaction flow because we have a unified mempool for every single type of account. We have our own bundler, which we call the operator, that sends the patches of the transactions to the entry point contract, which in zksync era is called the bootloader. And that means that having a single mempool, all types of accounts support paymasters. So if we go back to our ingredients for mass adoptions, we had two covered at the beginning, thanks to zksync being an L2. And now we have better user experience with the smart contract accounts. And thanks to paymasters, we can enable things like paying fees with ERC20 tokens or even gasless transactions, which will mean that for users, the technology can be transparent, but because they won't even need to know about what a transaction fee is. So we have all the ingredients for mass adoption. Now it's your time to build the apps and projects that will be used by millions of users. The main takeaways is that zksync era is scale Ethereum and reduces transaction fees. It's EVM compatible, supports Solidity and Viper and most dev tools. So you don't need to learn new programming languages or new frameworks. Most smart contracts will work out of the box with no changes required. Account abstraction and paymasters enable better user experience and different options to manage gas fees. And it's implemented natively on zksync era, which has some improvements over EIP 4337. Now, if you are a developer, you just can go to our docs. We have a lot of information about zksync. If you already have a project and want to know how to migrate it, we have a migration guide. And we have a lot of tutorials on how to create smart contract accounts, how to create paymasters. So yeah, you can go there and don't worry, I have a QR code for the end. And if you're a user and want to know more about which projects are in zksync, you can go to ecosystem.zksync.io. We have all of the projects listed there. That's also the URL to our bridge to send funds. And of course, our Discord and Twitter accounts where you can learn more. Finally, I want to show you some numbers about zksync era, because as you might probably know, we launched a mainnet like a couple of weeks ago. There it goes. We released a mainnet on the 24th of March. It was the first ZK EVM on mainnet. We have spent more than 12 months on testnet, so it's been truly tested. And in addition to that, we have spent almost $4 million on security audits and bug bounties. The current TVL is around $160 million right now. It just keeps going up. And on DeFi, we have around $70 million. Again, this just keeps going up. There is a lot of excitement about zksync era. On our ecosystem page, we have more than 200 projects. And yeah, we just want more people building on it for mass adoption. That's it. That's the QR code with links to all the links that I mentioned. So yeah, that's it. If you have any questions, happy to answer them.
All right, thank you so much, Antonio. So if there is any question, please raise your hands. Okay, I actually got some questions from online. So the first question for you, Antonio, is zksync are expanding to L3. That means hyperchain. Do you think that will be a big advantage over other decades? Can you also tell me how your L3 plans differ from Arbitrum and Starknet? Yeah, that's a question for you.
Okay, yeah, that's an interesting one. Layer 3s, or how we call them, hyperchains, are in the pipeline, and we know that there is demand for application-specific blockchains. So we will provide like a framework to build customized L3s or hyperchains, I would like to call them. And the improvements over other solutions, I think that will be that in our case, hyperchains will be able to talk to each other and bridge funds to each other directly. So with other proposals looks like you need, if you want to bridge funds from a hyperchain to another one, you will need to go down one level to the L2. So down to the L2 and up to the other L3 or hyperchain. The solution that we want to propose is if all L3s share the same ZK circuits, they will be able to talk to each other. So the TVL, the value in general of the network will increase because it will be easier to integrate with one L3 or one hyperchain with another. I hope that answered the question.
Okay, thank you so much. So we got another question for you. Tell me where zksync stands with regard to the complexity of the zk process and its relationship to processing speed. That's the question.
Yeah, I'm not sure if I understand it correctly. I can give you some numbers. With processing speed, we are generating blocks every second. So transactions are almost instant. I guess that can help. Then with regards to generating proofs, we are working on our prover and we are making improvements like every single day. Obviously, this is a pretty new technology in general, and generating proofs is a very computational, it has a lot of computational costs. We will release new versions of our prover over time, and that will reduce the times to generate the proof and the costs. And in the long term, well, I'm not sure how long term, but like our plan is to decentralize the whole network, the provers included. So everyone should be able to run a prover and generate the proof and generate proofs for the network.
I see. Thank you so much. So I think if there's not other question, then we'll finish this. Okay, so thank you so much, Antonio, joining us today, and that was our pleasure to have you here. Thank you, and we hope to see you in Japan sometime soon.
Yeah, I would love to go back.
Yeah, you should.
Thank you. Bye-bye.
Bye-bye. Thank you.
Thank you,
Yeah.
Antonio. Bye-bye. Bye-bye. はい。でしたらですね、これで最後のセッションが終わりました。お疲れ様でした、長丁場。で、この後ですね、ちょっとお寿司をちょっとたくさん用意してますので、皆さんで乾杯しながら、ちょっとネットワーキングパーティーしていければなと思うんですけれども、ちょっとその前に、今回入り口でもお配りさせていただきました別のちょっとカードについて、ちょっと最後にまた勘太郎さんからご説明がございます。はい。
はい、すみません、お疲れ様でした。ちょうどこの朝始まる時にも、一応説明させていただいたんですけれども、入り口で配っているこの NSC のベスカードというのを今お配りしてまして、今日これ読み取ってセットアップしていただくと、今日あったよっていう証明を発行できたりとか、あと経歴書としても使えますというところで、ちょっと朝最初にちょっと言い漏れてしまったんですけども、今この僕らで作っているこの別の経歴書を使って、ジョブのこの経歴書を使える採用のプラットフォームみたいなのを今、作っています。ちょうど2週間ぐらい前にリリースしたんですけれども、シナプスっていう名前で、リリースをしています。はい、で、この QR コードから読めるんですけども、この埋めていただいた作っていただいた自身の別の経歴書を使って、Web3 の仕事に応募ができたり、するようになっています。で、一応今ちょっとまだ掲載始まっている企業さんは10社ちょっとぐらいで、ちょっと今日、話していただいていたBTQ さんもさらに掲載していただいているんですけれども、他にも、ポリゴンとか、バンクレスジャパンとか少しずつ掲載が増えてきていまして、今後もちょっと掲載企業とか増えていく予定なので、ぜひ触ってみていただけたら嬉しいです。はい、すみません、お時間ありがとうございます。ありがとうございます。
はい、ありがとうございました。でしたら最後にですね、ネットワーキングの前にちょっと写真撮影をせっかくなんで皆さん集まってるのでやれればなと思ってますので、ちょっと一旦前の方にお集まりいただいてよろしいでしょうか。ちょっと前の方にお集まりいただいて写真撮影ちょっと最後にしたいなと思っております。これをちょっと、はい、じゃあちょっと前の方にお集まりいただいてよろしいですかね。 そうですね、ステージの上に乗る感じで。これ音楽ちょっと BGM はい、配信は落として大丈夫です。じゃあ、オンラインでご視聴いただいてた皆様ありがとうございました。また明日もデイツございますので、ぜひご覧になっていただければと思います。はい、明日はまた現場でもお待ちしておりますので、よかったらぜひ足もお運びください。じゃあ一旦オンラインの方は締めましょう。じゃあご視聴ありがとうございました。